The scope, we're going to talk a little bit about the scope of work and the scope that we are involved with when it comes to uh, providing services for our clients, which is generally stair structure, stair railings, miscellaneous railings, trims, maybe some panels, and how that information in terms of what we are supposed to be providing is usually passed on to detailers so that if you start on a new job, you'll know what it is that you need to draw and what kind of materials to use, what kind of finishes to apply, and all that fun stuff. So we'll go over that. And we'll finish off with something called drawing quality, which is maybe a little bit irrelevant nowadays if we are using modeling to provide or to automatically generate our drawing views for us with whether it's Advanced Steel or SolidWorks or any other 3D application. There's Tekla. There's I don't think anyone's really used Rhino. There's Inventor. There's yeah, you can even use plain vanilla AutoCAD to do modeling and generate drawing views. So it limits us a little bit in terms of how we present our plans or elevations and whatnot, since it by default shows all lines for all items. But we'll dive into that a little bit, and we'll talk about things like overlapping dimensions, how to place your text, layout on your page, your drawings and your details to try and make it clear for everyone who's reading it what it is that they're looking for. It's possible that that's been covered by Dan White, and I'm maybe kind of adding on to what he's saying, or maybe repeating it, or worst case scenario, maybe I'm just kind of overwriting what he's saying. If that's the case, take Dan's word over mine first. And if it's something that I am talking about that Dan's already covered with you guys, feel free to let me know, and I'll make sure to adjust what it is I'm talking about so that I don't add confusion to the whole mix of training that's taking part between myself and Dan with regards to you two. So before we start, are there any questions or comments?
I'm all good on my end.
Okay. All right. Well,
you know what?
Yep.
There is one that just I thought of when you were saying with the geometry and just drawing it. And does Advanced Steel have the ability to write formulas into your dimensioning? That's a feature of SolidWorks that I used to use a bit when I had dimensioning issues that or dimensions that wanted to be driven off of a fixed dimension.
Right.
And so I could incorporate that into a formula and always drive the dimension. If one changed, everything else changed accordingly.
Yeah. So I'm not sure about Advanced Steel. I know in AutoCAD there's dimensional constraints, which you can use formulas. Use the length from this dimension times 2 or whatever divided by 12. You can do basic formulas that way.
Okay.
But when it comes to modeling in Advanced Steel, unfortunately, since it's built on the AutoCAD platform, AutoCAD, the dimensional constraints that I was talking about, only works in 2D. It doesn't work in 3D. It won't move or modify any solid components or modeled parts that you have. So unfortunately, unlike SolidWorks or Inventor, dimensional constraints can't really be used for modeling, to my knowledge. I haven't seen or heard anyone be able to incorporate that. So yeah, it's a regrettable feature. It'd be nice to have. Advanced Steel really relies more on the use of macros to generate your stair shape, heights and everything else, and you would modify the macro to automatically resize the stairs as per your requirements. It may not be able to do everything that you want it to do. So you definitely don't have that flexibility that you would have with SolidWorks or Inventor.
And like you were saying, it might do it internally similar to what we were watching with the construction of the stairs, is if you change the dimension, it
Mm.
will it will adjust the spacing automatically. So
Right.
there may not be a need for something like that with the way this is functioning. So,
I mean, yeah, for your general stair layout, you're like you're saying, and you're right. The macro would like space things out, say like your stair nosings, for example, your tread spacings and all that would automatically be calculated from your first point, your first work point at the bottom of the stair to your top point, your either your top landing or your top of the floor. And it would take that overall height and divide your risers equally and remodel it. So if you change your overall height, then it kind of resizes all your riser panels so that, they're all equal. So yeah, that does kind of replace the feature that you're inquiring about in terms of the dimensional constraints. There are other times though that it would be useful to have, say if we do custom railings on top of it, where um, and this may be a more of a weakness for advanced steel or something that throws more of a complication for us is that, some of our railing profiles that we use or the, post spacings or handrail brackets or whatever, those are things that may not be handled very well by the stair macro, and we have to kind of manually add it to the model.
mhm,
And at that case, yes, dimensional constraints would have been useful so that if you edit the stair structure, you could have perhaps designed the
sure.
railings, handrail brackets and so on to kind of follow the new geometry. But it's a shortcoming right now since it's based on the AutoCAD platform. It doesn't do that. It's same thing with geometric constraints. So, and I'm pretty sure SolidWorks has that. I know Inventor does, where you can make two parts together and have them, centered like a hole, a peg in a hole. You can have those centered in the hole. You can have face-to-face mates. You can have,
Mhm.
I can't think of all the other ones there, but the AutoCAD doesn't have that either in its modeling. It's not that it can't be done for DWG files. I use another program called BricsCAD that can do things like that in the DWG environment. It's just that Autodesk, for whatever reason, decided not to implement that in AutoCAD. Uh, I It could be more of a marketing thing where they want to, if people want that feature, they should buy their Inventor software
Mhm.
and use that. So, and maybe they're trying to limit the cross-platform, like competition between different platforms that they own. So, uh, yeah, for dimensional constraints, unfortunately, there's just not much we can do about that. It's just not part of the AutoCAD and Advanced Steel package. We're really stuck with well, I say stuck like it's a bad thing, but it's the stereo macro that really drives everything.
Okay. Sorry to get you so far off
No,
on that
no
one. So,
worries, no worries. It's all good. And also just bear in mind, I'm fairly new with Advanced Steel myself. I've just started working on Advanced Steel for the past couple of months.
mhm.
So I'm certainly not the authoritative figure in terms of what it can or can't do. I'm learning as I go, pretty much like everyone else is right now. We do have someone who's a little bit more knowledgeable in Advanced Steel than certainly I am, and I would imagine the rest of the team. And I'm trying to figure out what was it Jason or was it
Yeah,
Tyler?
I've
Jason, I
heard
think.
I've heard Jason is like a guru.
Right. So again, going back to the engineering chat. So like, I assume you've got in chats on your teams, you have
Yep.
access to the engineering part.
Mhm.
And in that, yeah, just type away any questions you have. Like Jeanette's asked a couple yesterday before yesterday, and we're trying to help her through that one. And it looks like we were successful in that. And if you have issues or questions about it, or want to know if it can do something, yeah, feel free to just type in there, and if one of us knows the answer, we'll let you know. And if it's not something that can be done, we'll also let you know.
Okay.
So this is, yeah, it's going to be a team kind of session kind of thing. It's also possible that Edward might be able to approach Greatech separately. Greatech is a company that we are working with that is, well, they created Advanced Steel, but they also offer services for, I guess, creating templates and default packages for companies to use the program with. and do like modify their settings and everything else so that, it's customized a little bit more for a specific company's use. So with Greatech, it's possible that, they will definitely know a lot more than what we know right now, and they should be able to provide some better feedback as well if we have issues. So that could be like the last kind of resort if we have questions or problems about advanced steel that need solutions and none of us have it. Then yeah, Edward might hopefully be able to reach out to them and try and get something back.
Yep.
All right, so let's see here. Jumping back to training, checking. Okay, so we're going to look at checking what to look for specifically. So like I said, I'm not sure if you're going to be asked to check drawings or not. We do have a couple of, I don't know if I want to say like designated checkers, but we do have a couple of people that we rely on to check drawings more than others. Dan White's one of them. Unfortunately, from what I'm hearing is he'll be retiring sometime this year, which is sad, but good for him. I used to do some checking as well, the submittals, and there's a few others as well that does some. So since it's being checked by different individuals, it's quite possible that we're going to have slightly different styles in how we go about checking and adding notes to submittals. There's no real proper way of doing it as long as you're conveying the information that you need to pass on to the detailer so that they know how to revise or what to revise in their submittals. So let's talk a little bit about how we check with Bluebeam, and I'm going to see if I can pull up some examples here on my screen. So before I share that, let's see here. We're going to talk about when you're doing markups on submittals. I would, like I'm sure you've seen some markups from clients, architects, engineers, even the internal design team on a set of drawings. And what is useful to know is that everybody will have, or will try and use as much as possible, a different colored, different color scheme for their notes and markups, just to differentiate what, their markups are versus what might be someone else's markups that could be applied on the same drawing. There's no, as far as I know, Synergy hasn't exactly picked a specific color that checkers are supposed to use. You can see on my screen here, I used the hideous shade of green I could find. It looks, yeah, it looks weird, but it's a color I picked that I've known no one else has used so far. You feel free to use something else if your screen resolution or if you're colorblind or something and it makes it hard to see, feel free to use another color. As long as I said there's no kind of overlap with someone else's markups that has, say if you want to use red, but someone else already marked it up in red, try and switch a different color scheme. Let's see here. What else did I want to talk about? Let me just pull up try to go from memory here and have my age. That's an easy thing to do. So when you're doing checkings, I usually add a stamp to the first page of the drawing set, at least for a preliminary set of checks that I'm doing. And in it, I'll identify that the comments are made by myself, or if you're doing the checkings, add your name to it. When the drawing was checked, I try and add or include these little kind of like color blocks just to indicate what it is that, anything in those colors are my notes. And if there's like more than one color, what it is, like the function of each of these colors. So in this case, for this example, I have a light green where I use it's things that I verified. They're fine. Nothing needs to change. The darker one that's almost opaque, but it's not, it's like semi-transparent, is used more to indicate what needs to be removed or changed. So you feel free to use, something similar in your checks. I also like to add a brief summary of some of the major changes and issues that I found on the drawings, just to make it easy for the project manager to kind of get a quick look over. Instead of going through all the pages, they can kind of quickly reflect on the notes that you have on your first page and at least pick out the big major issues that you find. Some of the smaller things, it's not necessarily important to show in there, but if there's anything major like, oh, yeah, the floor dimensions were off, you're using the wrong profile or such and such, then it's probably useful information to list out in the front page. Also, when you're checking drawings, just maybe a tip more than anything, I find it useful to create sort of like a template sheet where I have notes or symbols or icons, anything that I frequently kind of use and add to drawings as I check, so I could just kind of select it. Let's just, if I were to set like this color, for example, then I could just quickly paste here and then just modify it as I need, as opposed to like drawing it out and then going in your settings and you know you're tweaking the colors whatever way you want. You got, there's a lot more mouse clicks involved and so on. So that could be something that you might find useful to have or to use. You can create your own if you want. I can provide you like this copy if it helps, and maybe start you up on the right path. And then you can build to that, build onto it. I've added sort of like some generic stamps on a curve sheet. So the example I showed you was like maybe one of the first checks that I've added, and as I've progressed with more drawings and other projects, I've kind of streamlined the system a little bit more and kind of cleaned it up. So I've got, like the stamps on the front page and whatnot. I can just copy it and paste it as I need and change whatever text that's in there. So I'll provide you that as a call it a starter pack, if you will.
That'd be awesome.
All right. Fantastic. We'll do that. Let's see. What else did I want to do? So I talked about things like, notes that I wanted deleted or changed. Like I said, I put in this darker color. I clarified what it is that I wanted changed. And you'll see that kind of everywhere. That some of these lines, like dimensions, I may have put them in red, just because the green looked a little too similar to the black and wasn't really popping out. So if you find that that's a situation, I don't see an issue with adding dimensions in red or any other color. Again, as long as it's not something that kind of matches or mimics someone else's markups that might also be on the same sheet or same package that you're checking. I will also, as I check drawings, add, if needed, little sketches or details if I find that it's kind of useful to explain what it is that I'm looking for in terms of what to revise. And I thought I had maybe a better example of that somewhere, but might not. I guess this could do it here. So for this example, I was trying to clarify that what was it? HSS there. Trying to clarify something here, and it had to do with the HSS stringer, and I think it's the clearance to the wall finish throughout the height of the floor. So I kind of sketched it out, and I've used different colors just to kind of pull out the different elements of the structure. So you can do something similar if you feel it's needed. If just adding text isn't really quite clear enough in terms of what you want done or why you think there's a problem somewhere, adding these little sketches can really help to help the PM or help the detailer or help anyone else really in the team get a better visual understanding of what's going on and what the issues are. So that's something else that you can explore doing in your drawings, or sorry, in someone else's drawing as you're checking them. And I've also, on occasion, as I check drawings, added pages at the end of a set to cut and paste maybe things that were done on a previous project, or maybe I'll just sketch something out in AutoCAD instead of trying to do everything in line geometry and Bluebeam, which is not always easy to do. But so, for example, this is a cut and paste detail from a previous project that I insert into this drawing, basically just to have them mimic the design of the handrail bracket for this application. Their design may not have been properly accurate. Similar to this sketch here, this was something else that I've added in just to illustrate the there's like an LED light fixture in this handrail, for example, and the detailer hadn't included that in their drawing. So I kind of showed, well, okay, include this detail, and this is kind of what we want to see in this detail to clarify where that LED light fixture is, what type it is, its orientation, and so on and so forth. In this case, I kind of crossed out the information from the other project that doesn't apply here. So in brief, yeah, well, as you're checking, feel free to add dimensions, feel free to add sketches, add details to the set, whatever it is that needs to be done so that the proper information is conveyed back to the detailer and the PM as well. And these are usually notes and checks that you're doing, usually stays internal. It's not something that gets submitted to the client. So in that part there, we don't have to worry about being hush hush about certain kinds of profiles that we may want to use that we don't want the client to know about or something. If it's a pricing thing or maybe a change that we just don't necessarily have to worry about getting their approval on. Your markups are internal to Synergy and our detailers, whether we have internal detailers or contractors. So that should kind of free you to add some markups without necessarily worrying about offending or causing concern from the client side. Let's see. We've been asked recently as well to add a standard when we're checking drawings, whether it's erection or part drawings. When we're done and we're checking in and we find everything's fine and it's good to release for fabrication or to release to the client, the engineering department wants us to add a final stamp on each page, like on all pages here, which looks something like this blurry image that I've got here. Unfortunately, that's not the actual stamp. Is it this one? No. Maybe it's this one here. It'll look a little something like this just to kind of clear it up. This is apparently it's a dynamic stamp. I haven't used it yet. This came out after I stopped kind of checking drawings and been a little bit more involved in the 3D modeling. But there's a drawing file that you can add to your Bluebeam folder somewhere. The sheet here that we're looking at is kind of going to provide you instructions on how to do it. And that should allow you to insert this stamp essentially as a stamp in Bluebeam. And you can add that to all pages. I don't know if it does it automatically, if you have to do it one by one. It might be written here somewhere. But yeah, the idea is, it's the official stamp of approval from us. So again, this only applies when you're done checking, you haven't found any issues, we're not expecting revisions to be done. You can paste that on there and every sheet gets one. So I'll link you with the spreadsheet that I'll send you. I'll provide you with the links to this file and the instructions and the stamp itself. And you'll probably need to try and figure out how to copy that to the, it's not showing me a picture here. What's going on? Yeah. Oh, well, you'll have to figure out how to install in your Bluebeam and make it work. If there's issues, again, reach out in Teams. We'll walk you through it. Edward can also help you out since he kind of created this process.
Question.
Yeah.
Is Bluebeam's University worth signing up for?
I don't think so.
Okay.
I haven't. Well, I haven't done any training with the university or frankly any other system. Bluebeam, I was kind of given to me and I just started working with it.
Okay.
There's, I believe, in Bamboo, and this may be some of your onboarding training that you're doing as well through Bamboo. I wouldn't be surprised if there's like some kind of a video about how to use Bluebeam or maybe some instructions on some of the key features that it does. I thought there was. Trying to see if it would be anywhere. Let me see if I can check maybe in files or something. Let's go ahead and employee docs on onboarding. What's nope. People info home. Okay. No, maybe not. Count. Nope. It's not my info. Wouldn't be in people. Oh, wait. Training, maybe? Nope.
Okay.
Yeah, I wouldn't, I don't think I would bother too much with like any separate training for Bluebeam. There should be something internally. If you can reach out to Edward if you aren't aware of it, but I'm pretty sure there was something about that internally that kind of gave you a good basis of like a good starting point to work off of for Bluebeam.
Okay. I mean, I'm pretty familiar with PDF type programs like this anyways, but it would, it'd be a good any kind of source of extra help just in case I, couldn't figure something out. That's all.
Sure. Yeah. I mean, if you feel like you need it, yeah, I mean, you're free to sign up for it.
Right.
But maybe check with the Edward first to see if it's something that the company would pay for, if it's an extra cost,
Right.
something like that.
Yeah.
There's also a lot of online resources. I'm sure if you just Google something, answers
Right.
abound are going to pop up in plenty of YouTube videos and everything else. So there's a lot of information out there that can help you out with that.
Right.
Okay, so let's see. So that was checking with Bluebeam. So let's go over a example of submittal drawings and what I check on submittal drawings, and submittals and erection drawings are essentially the same thing, except one has marked numbers and is revised to site conditions, and the other ones are like the preliminary set we sent to the client for approval. We're going to be looking at the cover page, make sure that our general notes are all neat and proper. If there's anything needs to be fixed in this case, okay, well, this was kind of like a minor thing, but I kind of was nitpicking here. But Synergy should be all capital letters. But ensure basically that the material finishes, the types of material that we want to use, the type of steel, the type of stainless or aluminum, the alloy used, any other special information, the glass panels, if we're having glass in our railings, for example, that the glass is properly identified and broken out into its key components, especially if it's like laminated tempered glass. I was going to try and pull up an example here somewhere that I could kind of show you. So many files. What's going on here? Synergy CAD. Where would be a good example of that? Oops. Why is this sideways? So like for glass, if it's tempered laminated glass, we kind of break it out into their components, the two panels with the interlayer in between. Fasteners, what kind of fasteners that we typically use for exposed or concealed fasteners or anchors. If we're providing wood treads in our guardrail package or stair finishes, it could be a wood handrail, it could be treads, it could be risers, it could be maybe some kind of fascia panel, whatever. Again, we'll try and break down the types of wood that we'd be using and any special kind of finishes we want. The adhesive structural grade, it's kind of optional there. So the big key things here, materials and notes, is the type of material and the finishes that we're going to be applying to it. These are in terms of the notes, we're only adding what we are providing. We don't add things that's by others. Unless we are working, and that's pretty rare. It'll be maybe brought to your attention if that's the case, but unless we're working really closely with a second subcontractor to provide us these other finishes, they may be relying on our drawings to provide, their sizing and everything else for their wood and finishes. In that case then maybe we may be asked to add, additional notes on their product, but I don't think that's really going to ever happen with us. We usually rely on the subcontractor to provide their own kind of breakdown of what they include and how they're going to finish things, so that if there's issues, we're not the ones stuck having to revise our drawings all the time. It's they can deal with the subcontractors directly.
Quick question. As I'm looking at this stuff, it just kind of sparks something I've been thinking about for the past few days. The information that we get, okay, as for I'm gonna how am I gonna say this? So as a detailer,
Mhm.
I'm going to be looking for a package from the project manager. I'm guessing that the project manager gets information from the architect, correct? As far as
Yes.
to what materials, what information, what hardware, and so forth is going to be provided. I was just kind of curious as to what that information looks like when it comes to us as detailers. Like, is it going to be a package of drawings? Is it going to be just a package of notes, or is it going to be kind of like a mix of the two, hand sketches, that kind of
Yeah.
stuff?
Yeah. No, so I get what you're saying. We're going to talk about that just a little bit later on, but it
Okay.
deals basically with the scope of work.
Okay.
And it's just real quickly, yeah, we do. I mean, we used to get a fairly detailed scope of work that would itemize all our um, like what we're responsible for doing and what types of materials to use. And there's a sample of it in our detailing team files, and it would ideally look something like, I can scroll down here, something like this, where it would tell you, all right, here's a generic part of what we're doing, like a you know for your summary, what pages on an architectural set you might actually find these drawings on, a quick description, and it would give you the inclusions, what we're responsible for, the types of material that we were mainly anticipating using, whether it's for structure, the tread risers, handrails, any finishes, and so on. However, different projects have little nuances depending on things like scheduling, and what type of services that we are providing. If it's we're doing more and more design assist projects. So
Hmm.
I don't know if you're familiar with those yet, or if anyone's talked to you about that. It's essentially the client, whether it's the architect or, well, usually it's the architect. They'll come up with a stair design. They're not too sure exactly how the stair is going to be fabricated, or what the major components are, like the stringer sizes and shape of treads and risers, that would work with engineering and provide, at least in terms of the design assist, a foundation for the architect to kind of include a little bit more detailing in their architectural set so that they can send it out for bidding or pricing. Well, that would be handled by the general contractor. But as a means of they're just adding a little bit more relevant information to the drawing that works with engineering, and so they can get their pricing. So that design assist phase can sometimes prevent us from getting these nice laid out scope of work items that we're working here.
Hmm.
And so you're going to be more involved as a detailer. You'll probably be part of the actual meetings that happen. You'll be involved in the first meeting, and this is where everyone's kind of introduced to the project. Uh, Here are the drawing sets that we have, and you'll be working probably more one-on-one with the project manager in terms of what they're looking for you to draw and model.
Hmm.
And then the whole process of the design is going to alter. It's going to change. It's going to, there's going to be some tweaks, and it's going to be, yeah, it's going to be molded to what the architect wants with each subsequent meeting as they see how we're designing it, and what they like and what they don't like. So that scope is something that would change week to week, and you wouldn't really clearly know what to use. Um, so we wouldn't have like this breakdown here that we're working with. Uh, Ideally, after the design assist phase, if we are awarded the actual stair project to fabricate, um, by then one of two things will happen. Someone in Synergy will actually take the time to break this down to a proper scope of work, and then something they use for their pricing, their fixed pricing, to fabricate and install the stairs or the railings or whatever it is that we're providing. And if we don't have that, then ideally what they should be doing is providing or ensuring that you have access to the meeting minutes during the design assist phase. And so as we're going through each meeting, typically the project manager will send out a just like a synopsis of what was looked at. So this would be an example here of what I'm looking at. So every week this may be sort of like a package of sketches and tables and charts and everything else are sent to the client. And as we make changes every week, then that's going to get highlighted somewhere. Say, like for this example here, the stair originally had a specifically shaped soffit paneling done on the underside of the stair, and then that's going to be deleted. So I think they just highlighted in red what we are providing now.
Mhm.
And so you're going to be tasked a little bit more with working with these notes to try and piece together what it is that we're providing. If that's still not clear enough, then just reach out to your project manager, and they'll explain to you exactly what is involved in our work, so that you can detail it properly, and then add that information to the drawings and the cover sheet. So it's yeah, there's a desired process. We have a scope of work, and it's nice and neat, and everything, all the information's there. Or unfortunately, if scheduling is just too tight, then we're probably going to resort back to falling on meeting minutes and the email exchanges back and forth between the client and the synergy team. So it's you got to put on your detective hat a little bit and read through it all, and it could be a little time consuming, but sometimes we just don't have the luxury of having this broken down for us.
Thank you.
Okay, so let's see, what else was I talking about? So going back to checking, so we talked about the materials and finish notes that we want to see on the drawings. We also have on our cover sheet with drawing index, so we'll check that all the page numbers kind of match with what's on the set. The drawing description as well. And, also kind of important, the revision number, and that's going to be in the title blocks as well. We want to make sure that any actual revisions that are going to be sent out, if there's a change, like we talked about yesterday, that's also been included in the drawing, so check that. And, last but not least, check the project name. Let's make sure we're using the right project name for the job, and not kind of cutting and pasting from another project and oops, I forgot to change it to this job. That's going to look a little odd to the client when they're looking at drawings and say, hey, wait a minute, we work with Google. Why are you giving us something that says Facebook? It's happened. So just in a rush of things, sometimes it's easy to cut and paste things in there and kind of forget to change it after the fact. We have two fields on the cover sheet, general contractor and architect. Just check with the documents that you have, or if you have any questions, verify with the PM in terms of like who's our general contractor, who's the architect, and what the addresses are, so that we make sure that we have the right information on the cover sheet. And yeah, that's pretty much the check for the cover sheet. And then for the rest of the drawings, basically it's loosely speaking, I mean, we're kind of checking everything. The big things to check are the grid lines to stair on plan, and the floor-to-floor finishes in elevations, that they match either the architectural set, or if there's been some changes on the field dimensioning part, especially more relevant with the floor-to-floor, that those changes have been incorporated. We're going to So in addition to check dimensions, we're going to make sure that risers and treads are all equally kind of divided on a flight of stairs. So that's kind of important as well. If it's been revised after the fact and they just stretch out, if this was vanilla AutoCAD, they may just have stretched out this top portion of the floor to bring it up a half an inch. Well, did they actually, edit all the risers to reflect that, or did they just kind of add half an inch to the top riser, which would be a no-no? So we check our grid dimensions, our floor to floors. You should have architectural drawings. I don't know how else we could do drawings if we didn't have the architecturals to start off with. So you'll be comparing between the architecturals, and hopefully you have the latest set. So again, when you're asked to check drawings, make sure that you can bring the question to the PM and say, where are the latest architectural drawings I can check this with, and they'll point you in the right direction. Whether it's in Teams in the file system somewhere, which can be a little complicated to navigate through. I could try and give you an example here of the filing structure that we have. So for a project, in projects, you pick the one that you're working on.
Wait, where are you finding this projects folder?
So in Teams,
Mm-hmm.
you should have,
I mean, look myself.
there should be a projects folder in here somewhere, or it's possible it hasn't been set up for you yet.
I'm bringing it up right now just so I can make sure.
Yeah,
I do not see.
if you go over to Teams, there's a little icon on the side. It says Teams.
I don't see anything on the side that says Teams.
Are you
in
on the
Teams?
app or the web?
Oh wait, I thought you were in a file explorer.
No, no, this is
No,
this is
you're
actually
actually
MSS.
in Teams.
Yep.
Actually in Teams. Okay. Okay. So then on the left hand side of Teams, it should say what? Synergy.
So on Teams, if you click on Teams, you should have access to operations, detailing, team, and projects folder.
Yeah, see it.
Right.
A button on the left, Teams, right below the chat.
Oh, there. Okay. I thought you actually meant Teams as in like
Oh, both
the.
actually.
Okay. Okay. Yes, I see projects.
So what I do with the jobs that I'm involved with is I'll I'll look it up in their, the 82 hidden channels, which is basically a list of all the projects that we're working on. And if you if you select it, it'll pop up on kind of like your recent files structure, and then you can pin that, and it'll stay permanent on the top of your screen there, and it'll give you easier access to it, get to it as you needed. And when you go in one of those folders, you have up here posts and files. If you go under files, here's where you start seeing the whole project folders and files that we have for the job. And most of the time, we'll be working with the section 8, which is synergy drawings and engineering drawings. And in there is where we will install our submittal drawings, or sorry, not install, but copy over submittal drawings or fabrication drawings. If we're looking for architectural sets, it's, I believe, in item 7. 7.1 is the drawings, and there you should find the architecturals, structurals, and any other sets that are given to us if they're available. The folder may be there, but it's not necessarily populated with any files. That's because we didn't actually receive in this case, a civil set of drawings. But if you win the architecturals, then you should see kind of the PDF or DWG or both, or even a Revit file sometimes of the drawings, and hopefully it's structured in a way that you can find the latest set to work off of. So if you're in doubt with regards to are the architectural sets the most recent version, again, reach out to the PM and they'll confirm or find out the answer for you. Just make sure that everyone has the relevant information, latest up to date stuff. It's not always automatically like uploaded to the system. It's something that's manually done. So it's possible that the PM may have received a revised set of drawings, but just hadn't had the chance yet, on the same day or the day after, to kind of upload it to the system. But again, when you do checking of drawings, they should be able to give you an idea of where all these relevant files are located. Let's see, what else was I going to go over here? So that's we talked about grid line openings. Grid line to stair. Openings in stair structure. We don't really have. This is maybe not a good example here for that. Maybe it is. We'll also want to check any openings in the floor slab, whether it's for installing our stairs up against or for future installation of our guardrails. We want to check that the dimension of the floor slab opening matches what we've surveyed. If we don't have survey information, it matches what's on the architecturals, and that the pertinent dimensions, especially like to a control line or a grid line, is also included. This helps the installers kind of double check things before they install. Hopefully they double check to make sure that what we've drawn and dimension kind of matches the actual on-site conditions, and there hasn't been a misunderstanding somewhere of what dimensions and how it was relayed to us. Sometimes, it happens. We're all human. We field measure something. Maybe if it's just with a measuring tape and you pull a dimension and the tape says 76, but your mind says 67, and you write it down that way on your sheet. I've seen it happen a few times with different people. So it's sometimes errors are made. It's unintentional, but it can happen. So that's why it's important that we also dimension out grid lines. I mean, the opening is wherever it is in the building, but for us to coordinate with other trades or finishes, and sometimes these drawings are forwarded to other contractors as well for maybe their scope of work that ties into ours. Having references to grid lines or control lines is important. Check also, and this is something that I've seen happen, unfortunately, check that the design of the stair matches, in principle, what's on the architecturals, or at least what was discussed and reviewed in the design assist. And what I mean by that is, like the shape, obviously, hard to miss that, but also the quantity of treads and risers that we have in a flight or in a run of stairs between like landing and floors or overall. I've had a project called FRB. It was started off by another detailer, and then it was handed over to me later on. And the original detailer, it was a U-shaped stair. You had a stair starting like at bottom corner, and it went to the right, it moved up, and then it returned back to the left. And so it was composed basically of 3 flights with 2 landings. And the detailer swapped out or moved a tread and riser panel from like the upper flight of stairs to a lower one. And I don't know if that was accidental or if they did that deliberately, but didn't explain to us why. And it threw off some of the connection designs that we had in terms of how the stringers are mitered together nice and clean. And it caused a few little problems. The architect didn't pick up on it, or if they did, they were okay with it. But it's one thing that we need to just keep an eye out, is just to make sure that, when we model or design something, sometimes we see 10 treads, but we, for whatever reason, we may model 11 or 9. Or on the architectural set, there may be a tread that's flush with the top of the floor. So it's something that might be inset in a concrete slab, for example. And on the architectural drawings, they'll actually count that as a tread. And so that could throw people off when they're modeling. So just to check with the stair sections to make sure that, we have the right number of risers and treads to match what was the original design. We're going to check things like welded joint connections. Are the weld symbols properly added on? This one here was a weld leader that pointed to, concrete, which is hard to weld. So, just little things like that. So it's pointing at the right object, at the right joint, the right size, the right type of weld we're displaying. And I'm pretty sure you guys know your welds, or the basic ones at least. Fillets and groove welds are the 2 main ones that we use. We have fusion welds, butt joints, or fusion or butt joint welds. We have plug welds, maybe a few others that we kind of use here and there, but like our 2 main ones are going to be, or flared beveled welds. But the main ones is a fillet or a variation of a groove weld. So just making sure that that we get the proper welds. Usually we'll have engineered sketches by this time that you're checking drawings. So check with the engineer sketches that they provide, and if they've included a weld type that they want you to use, and a size, and maybe a spacing. If it's a longer seam, they may specify a 2-inch long weld every 12 inches or something. So just make sure that information is all there and it matches the engineer's sketches. If it doesn't, and there's an issue later on, we are liable for it because we are not following what the engineer required us to do. So kind of critical that the welds match. If there's an issue with the weld, or if you think there's a problem, again, bring it up to your project manager and get their feedback. They'll reach out to the engineer, or they'll give you the final go ahead as terms of what to use and how to proceed. So that's the welds. So what else? We talked a little bit yesterday about splice joints in stringers. So anytime there's a splice joint, if there's a CJP weld, how it's we're adding a new detail clarifying how it's done. I don't think I have it in this set. This set here was done before we had that issue. But yeah, just fall back to what we talked about yesterday for the splice joints. And just make sure they're detailed correctly. If it's a mechanical joint, make sure that that's detailed correctly. If it's bolted on, and also verify that it's placed or at least shown on the stair overall sections or plans where those joints are located. These are things that are going to be useful for the site guys when they're piecing together the assemblies to know where the splice joints are. They can formulate their plan of attack when they show up on site and figure out how they're going to go about installing the stair. In this instance here, I'm not sure where those splice joints are, if there are even any. Yeah, it's somewhere. So we'll check splice joints. We'll check, yeah, we talked about material finishes and notes on the cover sheet. Any specifics that the engineer may want us to show in terms of connections maybe to the floor slab, whether it's for a post or the stair stringer. Make sure that the drawings have matched what the engineer needs. The engineer won't snap our drawings unless we match what they've sketched and what they've approved and calculated. We'll check if there's any materials on the drawings shown that is not something that we would provide. Like we would typically draw submittal drawings to show, at least the finished treads and risers and finished floor slabs, terrazzo, whatever it is that the composition is for the floors. If it's by others, we'll do our best to mark it up as being by others. If it's not marked by others, if it's just a note that says, like, I don't know if I could pull up an example here, but say, for example, there's a note that says wood tread. But if it doesn't say by others, the client can potentially come to us and say, oh, you guys are providing us the wood treads. Fantastic. We didn't know that was part of your price. We don't want to be in that situation where we're kind of stuck having to provide it now because we kind of hinted that it's something that we are including in our final product. So important to note that anything that's not by us should have the by others identified in your drawings. So we'll check for that as well, which kind of ties into, that scope of work. What are we providing, what we're not providing, the exclusions and whatnot. We'll check, in addition, we'll check our title blocks in all projects. We'll make sure that we have the right project number in there, that the drawing numbers are following one another, incrementally. Project name is properly listed. Who it's drawn by and the date that it was drawn. The general contractor, make sure we're using their actual name and not, someone else's. That might have been a cut and paste, which is not really something that we should be doing with Advanced Steel anyways. The architect, make sure that their names are in there properly. We don't want to insult them by, again, kind of like thinking that they're Gensler when it's actually Cushing Terrell. And the revision title block is, the revision block, is also properly updated if it's required. So if this was a set that was done, say after we had our first client review, that we would automatically default to revision 1. So what you're seeing here are letters, and this set here that we're looking at, which is, I don't know why I'm showing this as an example, but yeah, it should have been numbered as per what we discussed yesterday. It should have been a revision 1 issued for approval with the date, and it will always stay revision 1 until we send it back to the client and get another set of approved markups from them, or revise and resubmit, whatever the case may be. Let's see, and if these were erection drawings, and yeah, I guess they kind of are. Make sure that they have all the mark numbers for the assemblies or individual parts. So STR2 would be the assembly for this particular stringer, stringer and treads and risers. That's all in one package. If there are individual parts like treads that may need to be remove so that they can install things easier on a job site. Like this might have been a situation where possibly the top tread would have been removed and shipped separately. Then ensure that it also has a part number so that the guys on site know that, this part here goes, well, there. So we check the mark numbers. Well, usually by that stage, if we check mark numbers for an actual set of erection drawings, you also have the assembly and the fabrication drawings. So we'll look at that real quick. Let me see if I can pull up a sample of that. Before we jump on to checking fabs and assembly drawings, are there any questions on what we've looked at for the submittal and erection drawings?
So far, no.
All right, it's encouraging. Let's give me a quick second here to pull up a sample of kind of fab and erection. Let's try maybe this. So this is a smaller assembly drawing for a stair between two floors. So when we check that, I don't think I have much markups here, do I? No, that's pretty much a clean set. Is there something older I can check? So let's try this one here. Oh yeah, okay. Oh wow, yeah, colorful. So yeah, when we check our assembly drawings, we're obviously checking that they match the like the shape, the size, the dimensions, number of treads, and everything else. It matches with the submittal drawings. So if I get a set to check, I'll have the submittals, the assembly, and the fab drawings. I check the submittal drawings first, or I guess the erection drawings. And then when I check the assembly drawings, I compare that with the erection drawings that I've just checked and make sure that all the dimensions, like the overall lengths, or splice joint locations or tread locations, they all kind of match what was on those erection drawings. It shouldn't be an issue with Advanced Steel since the models are, working from the same master file, if you will. So if it shows up as one way in the assembly drawings, it should obviously match with the erection drawings. What I'm saying might apply more for AutoCAD, or if we are contracting out these drawings outside of house and whoever we're contracting it out to is using something other than Advanced Steel, that we may end up in a situation where they've had to kind of draw this separately from what they have on the erection drawings. And so that we might run into a situation where they don't exactly match one with the other. Let's see, the assembly drawings should only show parts that are going to be shop installed. It shouldn't show any like loose anchor bolts or plates that are going to be shipped separately on site. So in this case here, the bottom steel plate was supposed to be shipped separately, but they've included it in their assembly drawings. So I kind of highlighted and added like this is going to be shipped separate. Don't include it in the assembly drawings. We don't want the guys in the shop to kind of look at it and say, hey, we should be installing this, but we don't have this plate. What's going on? Or maybe they do and then they accidentally install it. So assembly drawings should only show what we're fabricating and putting together in shop.
Okay.
Right. If there is a loose plate, like I said, the mark number for that should go on the erection drawings, so that the installers usually on site, they may have a copy of the assembly drawings, but they'll primarily work off of the erection drawings, which gives them their floor to floors and where the stair is located in plan with grid lines and control lines. So any separate loose parts, any loose anchor bolts, plates or miscellaneous things that are shipped to site separately is generally not included in the assembly drawings. So we check for that. We check that the quantities is accurate. So in this case here, there's just this one stringer assembly. If we had multiple floors and all these landings to landing sections here were identical, and by a stroke of luck, all the floor to floor elevations on site were the same, they match on each floor, then you might see here on the assembly that your quantities will change to show like more parts if it's required. If we have 4 floors and everything matches perfectly, then we should have had 4 assemblies of this type. So check the quantities and make sure that they match. Let's see. Oh, check the overall. Ideally, there should be a dimension, an overall dimension for the assembly. So from like the furthest point to the right to the furthest point to the left, which is the opposite of how I move my cursor. Furthest point at the top to the bottom of the page is indicated so that it helps the PM kind of organize the shipping, how it's going to be shipped and transported to the site to make sure that it fits on a flatbed truck or maybe another kind of truck, someone's pickup. I don't know. They will probably want to have that information, the overall size, so that they can make sure that everything kind of works out logistically speaking, from shipping out of the shop to the job site, and also for craning and moving this off of from where it's dropped off on the job site to its position inside the building just prior to erecting it. So the overall dimensions help there. So we'll want to see that. There should be a bill of materials included on the assembly drawings, and that usually breaks down all the parts and the quantities that you need to create this assembly. The quantities should kind of reflect the number of assembly drawing or assemblies that you're creating on this page. So if there's just one stringer here, then the parts should just be should reflect that and not necessarily be like, well, this HSS 12x4 at 9'3 1/4. Well, we use this in another location, so you're actually going to have more than one. That shouldn't be the case, right? Like a bill of materials should reflect what's being displayed on your page for the quantity that's required of this assembly. So we check that. We check. We're checking everything. That's just what we do. It's checking. It's boring. It's tedious, but it needs to be done. Title blocks information. Assembly drawings will usually have, so if it's steel or something like that, we'll usually have a finish applied to it. In this case here, we had just a standard top primer finish applied to the steel. If there's something special, if it's, I don't know if it's supposed to be painted, we'll add the note, paint to match either approved sample, or if we have a specific, like a spec from a specific vendor, we'll add that information. It's quite possible that you might not have enough room in the area of the title block to add any more specifics if it's required. If that's the case, just say in the finish, or materials, just say as noted, and then add a note somewhere on the page, probably near the title block, where you can list out in more detail what the finish is, like shop primer finish followed by powder coat, whatever, so vendor name, number or color, any of that information. So we'll check that the finishes match what's on our contract. Check that the materials and assemblies, it's not always going to be listed because assemblies can be made up of different material types. So as noted would generally mean, check with your bill of materials, and your material type should be listed there. So we also check that. We check the page numbers, project name again, work with drawings. I usually use this to indicate what page on the erection drawings this assembly should be found on. So that when it's shipped to site, when the installers, how can I say this? Not just necessarily installers, but even like the project managers, if they need to double check something or they want to figure out where this stair goes or where this component, you can at least reference back to the erection drawings and say, okay, well, you'll see this assembly on page, I don't know, this instance 3 of EO3. And so if they look at the erection drawings, they'll see right away that, oh, it's this stair here, so that goes there, and they'll understand what's going on, and they can communicate with their installers, or vice versa. Maybe their installers have a question and they need to kind of coordinate between the erection and the fabrication drawings or assembly. So I'll add that information in the title block as well. So check that that's kind of accurate if it's included. We talked about the weld sizes. Yeah, we talked about weld sizes for the erection drawings. It also applies with assembly drawings. If there's any welding, that the proper weld is displayed, and that all welds, not necessarily for every single joint, but like if there's a component that has multiple different types of welds applied to it, that it's clearly laid out, like labeled or identified in some way. If they need to add a quick little detail somewhere, they can throw something in on a secondary page and show like, yeah, this is an old spice joint here. But help to clarify what kind of welds are being used where. And the last thing, kind of obvious to most, is just make sure that there's enough dimensions on the drawings that the guys in shop know how to fabricate it and are able to put all the pieces where they need to go. If in doubt, try and ask yourself, if you were tasked with putting this together, do you have the information you have on these drawings to fabricate it or install it from the parts that would be given to you? If the answer is no, you don't know where you would install this tread because you don't have a reference point, then you would know to add a note saying that we need a dimension to this point, or we need more information as to where this is located. So I mean, it's easier said than done, asking you to like put yourself in the mindset of a shop and a fabricator or maybe a site erector. It's not what we do, but try and think of it if you can from their perspective. They're looking at that drawing and they're not necessarily going to have the insight that you do from working with the job as involved as you would be, having seen the architectural drawings and the engineering drawings and everything else. So yeah, for me, more dimensions is better than less.
Yeah.
Some might disagree. I don't care about them.
I agree with you.
Yeah. So
The drawings aren't for us.
exactly.
Right.
Yeah.
Drawings are for the next guy.
Right. Okay. So that's it for the checking of assembly drawings. Try to see if there's anything pertinent on this set here that might pop out at me. I think there was, what's this? Please do not create assembly drawings of single parts. Okay. And yeah, so I guess the other thing would be, and this may be more of an advanced steel thing. The way it spits out drawings, it spits out in two different packages. So it'll spit out drawings that are involved in assemblies, and then it'll spit out the actual part drawings. In the assembly package, there shouldn't be like a part drawing. If it's just one component, it should be part of the part drawing and not the assembly drawing. So in this instance here, I'm not sure what happened with this detailer, but he sketched out this landing pad. It's just a plate, and it should have been included in the part
Now,
file instead of the assembly.
when you say that, does that include any ship loose items and whatnot too? You
I-
don't do
yeah,
individual
so-
part?
Yeah, sorry. So ship loose items should be also part of the part drawings.
Okay.
So the part drawings are what's needed for the entire project.
Right, right.
Not just for the assemblies.
Right.
But
No, I
what-
was just curious if those were typically included as well, in the part, and not the part, in the assembly drawings.
The ship loose, no, it shouldn't be.
Okay.
Again, the assembly drawings are used mainly just by the shop that's fabricating and putting things together.
Right.
The part drawings can be parts made by other subcontractors, that we ship out to our main manufacturer. So say we have a contract with someone to fabricate the stair, but we are outsourcing, I don't know, perforated panels from another vendor at a certain sizes or precast terrazzo. I don't think it would be shop assembling precast, but I'm trying to think of another example here. Yeah, anything that's formed or like a special type of part with a finish on it or something, that we would have fabricated elsewhere just for pricing. And maybe it's cheaper to have someone else do it, and then we would ship it to the shop that's responsible for assembling the stair. We don't necessarily include those parts because that might confuse them into thinking they have to fabricate it themselves.
Okay.
The assembly drawings should only show items that are made of two or more parts. And yep.
Quick question, if we could go back to that plate.
Yep.
Okay, because I see two mark numbers on that. I see an actual part And I see, I don't know what you would refer to it as, but it's a M101.
Yeah. So that was what's going on here, and I'm pretty sure that was an advanced steel thing. Depending on, and I'm not exactly sure. I haven't quite reached that stage myself in terms of the modeling in advanced steel into generating assembly and part drawings. But I believe this plate was categorized as a assembly, even though if it's just one part.
Okay.
Advanced steel isn't all that intelligent when it comes to figure out that an assembly needs to be like multiple parts put together.
Multiple parts.
Yeah. So it's possible there was a setting that was clicked somewhere that said this plate should be an assembly, and so Autodesk, or not Autodesk, Advanced Steel will generate an assembly drawing and then list out the parts that the assembly is made of. So you ended up with these two numbers. You had the M101, which is the, I guess, assembly, miscellaneous assembly drawing for this plate. But since it's just a one plate, then the part drawing only has, the bill material only shows the one plate. And so that's your PL108 that might be up here.
So that's truly what the drawing should be referred to as, is the PL 108.
Exactly.
And everything downstream of that would be the PL 108.
Right.
Okay.
So in this case here, when I told them to don't include this in the assembly drawings, it should have removed the M101, and in the part drawings, we should, the part drawing should still show that plate 108, but since, I've asked them to delete it from the assembly drawings. I didn't want there to be any confusion and have someone fabricate like two plates. We just need the one. So assembly drawings only have multiple parts. And, if whether we ship loose to site or not, individual parts will be represented in the fabrication drawings, and it'll be included in only the fabrication drawings.
Okay.
You still reference a mark number in the erection drawings, right? They want to know where that PL 108 goes, but no,
but
there
by
shouldn't.
fixing what you were saying not to do this, the M101 would go away. That
Exactly.
would no longer be shown anywhere. Yeah.
Right.
Okay.
Yeah, so that was my instruction here, was to just tell them get rid of this page. We don't want to see this. And they did that with the smaller angle. And so again, they labeled this as an assembly 102, but there's a part drawing in here that's AN 102. So it got confusing. I don't know, maybe the shop guys see this all the time and aren't quite as fazed by it, but as a checker, my OCD was kind of kicking in there and saying no, we can't, we can't have kind of duplicate drawings and label them differently. So that's it for the assembly drawings. Any questions on that so far, other than what we just talked about?
Now you said just a quick one. It's not even really a question. Advanced Steel does all the numbering by itself.
Yes, it does. It does do automatic numbering. I think you have the means to kind of override the automatic and assign a specific number if you want to.
Okay. Do you
But
guys generally just stick with the automatic numbering though?
I believe so. I think for the most part, it seems to work out fine. There may be certain instances where you might not see that for stairs, but say for railings, for example, if we have glass panels and we have multiple floors, just for the shipping of the glass panels, because they're going to be shipped on like an A-frame, and you'll have multiple panels on each frame.
Right.
For them to kind of set out the frames on each floor with the relevant panels, it's possible that the project manager may ask you, we've had a request from the installer or someone else, can you label all the glass panels on the first floor a certain way, maybe with a letter A or something like that, and then all panels
differentiate between. Yeah. Okay.
Yeah, exactly.
Yeah.
So doesn't always happen. Occasionally, we've had that request.
But we'll get notified though if that request ever does come in. Okay.
Yeah, exactly. Yeah. Otherwise, I would default to the automatic numbering. And again, if after that fact the PM will look at the drawings and say, oh, you know what? Yeah, I don't like the idea of having just numbers, and then sometimes they if you have identical panels on one floor with the next, you still have the same numbers, but that kind of breaks apart the sequence of numbering going on. And it could kind of start looking a little messy when you're at the fifth floor, And further up, you really start having like different panels. You might jump to like panels 92, 93, 94, and then panel 4 because it matches similar panels on the first floor or something like that. So yeah, they may look at it and say, no, I prefer to have something a little bit more specific or something. So you can override it as needed.
Okay.
Anything else?
No. If you want to hang on a minute, Bill had to step away real quick. He'll be right
Oh,
back.
all right, no problem.
Yeah. You were kind of answering my question, so he didn't want to interject.
That's fair enough. Well, he's gone. I'm going to take the opportunity to try and open up a sample fab drawing. Let's see.
Oh, I did have another question while you're doing that. Do you have
Yep.
any? I mean, do you specifically go anywhere other than our current training modules for advanced steel? Do you have anywhere else that you might suggest us to look if we want to get a little bit more specific into specifics,
Um,
or just kind
uh,
of just YouTube, Google it, and whatnot?
yeah, that's pretty much what I do.
Okay.
YouTube and Google it. It's
Okay.
it's not always simple. But if you Google, I usually try and do like advanced steel, I don't know, hatch missing.
Yeah.
There you go.
Yeah.
And you can look at the results. You can look at the
Right.
videos or whatever.
Well,
And
I used to know some guys when I was doing AutoCAD that had specific people that were doing like specific training modules that they stuck with that they felt were more in depth and more keen to the questions being asked. So I wasn't
right.
sure if you had like some specific tutorial author or whatnot that you generally went to. I was just kind of curious.
Uh, no, not really. There's yeah, Advanced Steel is a bit of a niche product. It's not as popular as AutoCAD or Inventor or SolidWorks or anything else. So it's hard to find someone that's kind of made it their focus in terms of creating content,
Okay.
whether it's videos or training.
Tutorials.
Yeah. Um, I've seen a couple, and I'm trying to see if I can find one here. Advanced Steel, let's try tutorial maybe. There was one guy that comes to mind. Yeah, right here. So in Advanced Steel, this AirCAD, let me just mute that. This guy here seems to have quite a few videos on Advanced Steel. He's more structural detailing, like standard structural components in a building, as opposed to like stairs or railings.
Hmm.
Uh, but he seems to offer quite a few useful videos here near that I found helpful to look at. So if you Google EIRCAD in YouTube, you should come across his channel.
All right.
But again, when you're searching something, uh, as in a hatch, I don't know, maybe this again, you'll probably see it. Yeah. So his one of his videos shows up there in the search results, along with a few others. It's really a question of searching through something and finding out. AutoCAD, there was a website I would go to that was like a forum. I think it was called CAD Tutor or something like that.
Hmm.
And it a lot of information. If there was something you were looking for, chances are someone else had that same question and it was answered already. So you can go on that forum and check it out. Or if you can't find answers there, you can kind of post your own question. You may not get answers right away, but someone would eventually get back to you. But looking at their site, they didn't have anything for Advanced Steel. It was just too niche. Not enough users, I guess, that really were asking questions about it. I haven't found anything else anywhere. Not that I've really looked all that hard, but I haven't really found any other like online forums or community groups where they help each other out with it when it comes to Advanced Steel.
Okay.
If I find something, I'll let everyone know. But I think for now, Google and YouTube are your best friends when it comes to finding additional resources for Advanced
Yeah.
Steel.
Because I know there's actually a couple groups on Reddit that do Steel SolidWorks. So I might look into that, see if they're on if there's anything for advanced steel on there too.
Advanced Steel Reddit. Let me see if I just. If I pop that, this Advanced Steel pros cons for anyone working in Advanced Steel. CAD, Commons, Autodesk. And it's just CAD, so it's not specific to Advanced Steel, but yeah, you might be able to find something on Reddit that can help you out. So there's a Revit group, AutoCAD group. Yeah, I'm not seeing anything specifically for Advanced Steel. CAD. Yeah. Well, you might get lucky and find something.
And the only Advanced Steel only has like 10 members that I saw.
Yeah, it's probably all of us. It's the whole synergy team. Yeah, no, it's like I say, unfortunately, like it's a bad thing, but it's a really niche program. It's very specialized, and it's just not as globally used in multiple applications like SolidWorks or AutoCAD or anything else. So it definitely limits the user base on that. And from that number, again, you're limited to who is used to being on the web and posting things and whatnot.
Okay. All right. Well, thank you for that. Appreciate it.
No problem. Okay, so we talked about assembly drawings. I'm going to jump real quick on fab drawings, and then we can move on to building codes. Yay. So let's see here. Now I want to bring up my own little treat what I wanted to talk about. So very much similar to assembly drawings, we are checking again, kind of like the same thing. When and maybe I should have mentioned this with the assembly drawings. Similar to erection drawings, on the first page, if I have room, I'll add a stamp, right, that says I checked the drawings on this date, major notes that I may have. If I don't have room on the first page to add all that, I'll actually insert a blank page at the very beginning of the package and then add my stamp, if you will, to it. And I do that for every different like file set. So whether it's the erection drawings, part drawings, or the assembly drawings, I'll usually add a page or a note somewhere on the first page where I can clarify that I did perform the check and these are my findings. Did I prove it or not? The part drawings, the main things that we're checking for here is that, the sizes and quantities match what's shown on the assembly drawings. So in order of checking, right, I typically check erection drawings and the assembly drawings and then the part drawings. So once you're comfortable that the size on your assembly drawings are correct, it makes checking the part drawings a little easier. You can double check with what's on the assembly to make sure that the overall lengths and sizes and profiles used match. Again, shouldn't really be an issue in advanced steel, but you just never know. Maybe the drawing just wasn't updated and they forgot to click on the update detail thing and this angle could have changed to 6-inch long or something. We check the quantities, make sure that's fine. And it's possible that certain parts are used in multiple assemblies. So don't just take for granted that you look at one assembly and you see that there should be an AN, there should only be 5 AN 101s, and then you go in the part drawings and, AN 01, you might see there's more than 5. Well, that's probably because it's being used somewhere else in another assembly, in a separate assembly. So in that case, you might have to go through all the assembly drawings and just make sure that you have the total quantities match. So, AN 101, you'll want to check all the other pages for an AN 101. And maybe I'll look at it. Yeah, right here. Here's the other one. So that would total my 6. So there's that little extra step there in checking. We will check that the finishes, if applicable, are included. Most parts will be finished once it's assembled, especially if it's prime or painted. Otherwise, as we're welding things together, we're constantly having to, expose the mill finish where the weld joint would be located, and that's just too time consuming. So it's easier just to fabricate everything in one big assembly and then apply the finish afterwards. So if that's the case, then I would typically add in the finish note on the title block, finish after assembly, unless noted otherwise. The unless noted otherwise kind of important. If we do have loose parts that we're shipping separate to the job site, we'll want to list it and make sure that the finish is applied to that part. So this angle here, for example, shop prime finish on all sides and ship to site separately. You wouldn't find this on any of the assembly drawings. So when we send it to the site, right, it's already finished if it's needed to. Bear in mind if there's any weld to it, we may have to add an additional note, say don't apply finish, along this edge. if we're expecting there to be a weld. I wouldn't worry too much about it if we forget it for like one or two small parts. Again, the welder typically kind of grinds away the material just to make sure they remove any rust spots and whatnot. It's a little bit more time consuming if they have to also grind off paints or primer finishes. But whenever possible, try and keep that in mind when you're checking drawings. If there's any loose parts, they should have their finish listed on that. And so we don't end up shipping things to site with just a mill finish. Let's see what else here. We'll check dimensions for parts. Again, put yourself in the mindset of if you had to fabricate this part, you have what you need to make it. So overall dimensions, heights, width, make sure that it helps you in terms of how you orient the profile. Angles, if there's miter cuts or any other shape that needs to be incorporated into the part. If there's any hole locations that we've dimensioned to the center of the holes, and I've seen a couple of occasions, and I don't know if I have an example here, kind of, but so here they've dimensioned to the center holes, which is kind of the standard. I had another job where they dimensioned to the rim of the holes, which I found peculiar. It's not something that's generally done. On the part, they'll take the plate and then they'll measure the center. They'll make a punch, and then they could just use a press drill or whatever else tool that they use to drill out the hole and then thread it if it's needed and whatnot. So dimension center of holes, overall dimensions, angles. Yeah, that's. I mean, dimensioning is fairly straightforward. Radiuses, make sure the radiuses are there if there's any rounded edges or corners treatments, if it's an end cap to an HSS or something, or a round part, that the radius is included. If we're doing folded plate, try and dimension to the outside face whenever possible. If you're dimensioning to the inside, also add a dimension that represents what the thickness is, but that should it's not really recommended to do it that way. Like it should be the outside to outside.
Just a quick question on that, then.
Mhm.
What if the inside dimension is the critical dimension?
That's a good question. It shouldn't really matter overall. Like when we fabricate things, unless we're designing a rocket for SpaceX, we're not going to be at the stage where we need to be a thousandth of an inch precise with our dimensions. Everything tends to be like a 16th plus. So even if it's critical dimension, I mean, if they don't bend it to the critical dimension, then the outside dimension also doesn't match, right? The plate thickness wouldn't change either way. So regardless, critical or not, if they don't match that dimension we're showing, there's a bust.
See, it's just to kind of the environment Tim and I have come from.
Mhm.
Everything was dimensioned to 3-place decimal, with tolerancing up to 5 thousandths on some things. And
Okay.
the reason I say that is if you get you get sheet of material where the thickness is not correct,
Mhm.
and we've run into this. That's why I asked the question. Sometimes we would be sent like a 7-gauge material that is not the same thickness as 3/16, but is commonly referred to as the same, in which it's not.
Okay.
So if they don't bend it to the correct dimensions, and now it's got to fit over something, and the inside was the critical to hold, the outside was not so important. That's what drove the question.
Right. No, I can see where you're going with that. Yeah, I mean, we don't. Sorry, go ahead.
Yeah, it sounds like it's not such an issue here, so it's just a question.
Yeah, it's like for the type of work we do, our tolerances aren't that, like I said, a thousandth of an inch or 3 decimal places, accurate. We don't expect people to show up there with like calipers and
Okay.
whatever to figure out like is installed to within the width of a hair. There are parts we've done in the past. We've machined out parts, special fittings and whatnot, where that you did need that high tolerance, and you also include like a plus or minus, 0.005 inches of tolerances here and there. That's kind of rare and not really something I think that we do much of anymore.
Mhm.
And for the stair, for the fabrication, even if we're off by a hundredth of an inch, I don't think it really matters overall. It's unless your stair has 100 risers to it. If your plate is bent a hundredth of an inch longer, it really shouldn't matter all that much. So I guess to answer your question, sorry.
We did more than just stairs, and that's why I asked the
Right.
question is, some of the assemblies and weldments that we did were very high tolerance and
Right. So yeah, and again, I can understand where that comes from. And like I said, we've done some machining, some very fine precision work type of machining, but it sounds like the direction that Synergy is going nowadays is we are focusing on um, like stair structures and railings, and those typically don't require as fine of a of a precision required. So we are pretty comfortable with showing like a 16th of an inch in terms of dimensioning. Yeah.
okay.
The only time I might, well, I'm trying to think if there's an exception to the rule. The 16th of an inch, I may show a 32nds of an inch dimensionally if it's something like we're measuring maybe a part that has 2 or 3 holes or more holes or something like that, and I'm dimensioning from center to center to center of the holes. I may want to round it to a 32nds of an inch just to show less of that dimensional creep if it's a rounding thing going on. So maybe the real dimension here, center hole would be instead of 1.5 would be 1 in what's half of 32 to 16. So it makes like 1 in 15 30 seconds. And then you add another dimension, and then at the end you have another dimension. AutoCAD rounds it to a 16th, but when you add everything together, you don't get your 1 foot overall. We've had a couple of examples or a couple of situations where the shop guys kind of came to us and said, "Hey, I know you're showing this dimension, but when you add it up, you're off by 1/8 of an inch from your overall. What's going on?" And then you're stuck trying to explain. Well, it's how you round numbers. If it's a 30 seconds of an inch, CAD will round it up to the nearest 16th unless you specifically state that you want it measured at a 30 seconds.
Mhm.
So I don't do that frequently. More often than not, holes, if there's a dimension between and they're like equal, I may just say like dimension or like from the first hole to the last hole, say, okay, there's going to be 6 holes equally spaced at that, and then call it a day. Or we'll use ordinate dimensions. That could be another way of solving that problem, but it's not really something that we typically come across as a need to be a little bit more precise with our dimensioning. So yeah, I think for the most part, like the decimal places, we're kind of shifting away from that right now. We may come back to it later on, because I did used to do part drawings myself with decimal places, but we've had some shops complain that, well, our measuring tapes are like in 16ths of an inch, right? What good is it to us to have decimal places? We can't measure it like
Exactly.
that. So I mean,
Yeah.
I kind of get where they were coming from. Yeah, the decimal was just more like for me, so that when you add things up, it didn't really get like you didn't have too many dimensional like creepage going on that would throw off your overall dimension. So I mean, hopefully that kind of answers your question.
Oh, yeah. No,
It could
It
be,
does.
yeah. We may work on a special project where we are machining parts and we do require that tolerance. And if that's the case, I think for the most part we'll be made aware of it. That hey, we're machining this. It's going to be put in a CNC machine and so on, and we need to show the tolerances. And at that point there, then yes, you can kind of like make a special override for that one dimensional part. That dimensions should show a higher degree of precision. But for bent plate, bar stock, and all that stuff, it's yeah, 16ths of an inch is generally pretty good with us.
Okay.
See here. So, other things to check again for parts. We're just going to wrap this up real quick here. Holes, we're going to make sure that the labels for the holes are included and that they're clearly defining what kind of hole it is. And if it's threaded, the thread type we use. So if it's, I don't know, for example, if this was supposed to be uh, heck, I don't know, like a number 10 threaded hole, it would be a number 10 by maybe 28 if it's a fine thread. Wait, is it 28 or 32? I think 32 is a fine thread. And 28 is a coarse, or 24. I don't know. I have a list here. I have no sheet of paper I refer to for that. But, fabricators need to know what type of holes they need to make. So for that, the proper information needs to be included. We wouldn't normally like list out if it is a threaded hole. I don't normally indicate like, okay, we'll use a drill bit of this to create your initial hole and then come back with your tapping, your tapping tool to create the thread of like, like I said, number 1032 or something. I just indicate it's a number 1032 hole, threaded hole, and that's the shop guys should have all the information they need there to create that hole. If it's countersunk, it should show the geometrically it should show that it's countersunk, have a secondary line that represents the the countersinking of your part as you fit that between your plate. So say this is your plate, right? You have that there, you have this here, that there. So ideally you should see a circle that represents the outer rim, and then you should show a circle that represents like the inner part. Just so graphically, it's instead of just relying on a note, they can also visually look at it and say, oh yeah, there's something funky about this hole. It's probably countersunk or counterbored or something. If the part is underneath, like if the countersinking is underneath, ideally this would be like dashed or something, right? However, we're getting to this point now where we're adding multiple parts on one sheet. And so the scale of these parts are going to start getting really small, and the dash lines may not necessarily kind of clearly show up. It may just look like a continuous line. If that's the case, I might ask the detailer to include maybe a side profile,
or even a note for far side, probably.
Yeah.
Yeah.
I like it. I like to visually show the side profile a little bit more than just a note. The note works fine too.
Yeah.
Just sometimes, I don't know if it's a language barrier, but they may not necessarily recognize what the FS or NS might represent, near side, far side, and or when you're looking at it, or you look at the far side, which is a no-brainer to us, but not everyone's experienced reading drawings and understanding that that type of language. So if you show like a side profile and you're clearly showing how the countersunk hole would be drawn, then graphically that's helpful to them as well. Advanced steel defaults, I think right now we have by default these holes are hatched solid, like so you're seeing the solid black. I'm not a fan of this. I've overridden this myself. So
I don't like it.
Yeah, no, neither do I. My concern, and I've seen this on another project, was that we had a countersunk hole, I think it was, or counterboard. There was something going on. Oh no, it was an HSS tubing that had a certain size hole on one side of the tube and a different size hole on the opposite. I'm not exactly sure why that was, but we had that situation where on the part drawing, it solidly hatched the larger hole so that you couldn't see the smaller hole on the far side. Right. And the far side holes, well, they weren't in all locations that you had on the near side holes. So maybe if you had 4 holes on the near side, then the far side you'd have maybe just 2 of the holes would have a different, smaller size hole on the back end. So yeah, the solid hatching is something. There's a setting in advanced steel that I found that allowed me to turn that solid hatching off, and I think we're going to.
Again, can you forward that to us so we can make sure? So, or at least for me, I would like to have that turned off.
Yeah, I have it. I actually made a spreadsheet here somewhere that lists what I've turned on and off. It's probably this guy here. Change that I made. So this is more for me to keep track of what I've changed from the Synergy default. If there's ever an issue, or if they release a new package from Great Tech that has all the standards, and then it might override what I've changed. So you're looking for holes should not have solid fill. So the default is in your drawing presentation hatches, which would
Okay.
be the drawing presentation and hatch. Where's management tools? And I think it's in default drawing
Hatches.
presentation here, general, and there should be somewhere something that holds display. I just gotta find this stupid thing now. So the angles, triangles, running height. Am I looking in the right spot? General? Is that what I said? Drawing presentation matches. Drawing presentation. Oh, so, yeah, okay, right. Derp. Yeah, so I had the hatch pattern type hidden holes. I just removed these. I think it's a setting. It may be alternating from 1 to 0 or something else. I can't remember exactly how that worked, but I think I just set it to 0 and it should fix it. Yeah, so I just made it equal 0. So hidden holes, visible holes.
Yeah.
I think if you set it to that, it should get rid of that solid hatching.
Perfect. Appreciate that.
No problem. I can make this file available to you as well if you want to kind of browse what it is that I've tweaked in here. Things
Okay.
like the weld symbols for some reason, when it was showing the sizes, like if it's how would I show
Yeah,
this?
if you just pop it up, we'll peruse it and whatnot.
Yeah. Yeah, there's a few little things there, like the angles. It by default we didn't have the actual angle measurement. Like it would give us the triangle that would show us the pitch of whatever
But not
part
the
or
actual.
yeah, not the actual angle. So there was a setting in there as well that I found that it turns it on. You know where yeah, right here. Wait, no, that's not it. I need to learn to read. There you go, right here. Slope dimension should include angle. So there's a checkbox there, displays angle information in slope dimensions. Just little things like that. Or I, if I create my drawing views for my plans, I have grid lines for whatever reason. The balloon for the grid line was always at the bottom instead of at the top of the line, which was driving me bananas. So there's a setting for that as well, that it defaults to just the top or both. There's a few things I found, and I might change this. And again, this is not necessarily Synergy standard. This is just my override, and I'm okay with it. Edward may say something differently to that, and at which point I'll have to probably revert back to our Synergy standard. But I plan on sharing this with Edward at some point, saying, okay, well, here's what I found. I think we should implement these changes, and if he's in agreement, then we'll probably approach Great Tech, and when they do future updates for us for our package, when it comes to standards that we use, drawing sheets and title blocks and everything else, they can make the changes to the settings and help us out that way. All right, so that's the holes I talked about. Yeah, and like assembly drawings, if you look at it, again, ask yourself the question when you're looking at the part, do you have the information you have to create the part? Are all the dimensions there? If not, then you know that you need to add something. Again, easier said than done. We're not fabricators, but I think most of us should be able to kind of piece it together. If you were given, I don't know, sheet of plywood, would you be able to cut out the shape that we're showing here? Or, if you had 2x4 or something like that, would you be able to cut the length and the miter and all that? Yeah. And if not, I'm sure the shop will let us know that they're missing something anyway. So one way or another, we'll find out. So that completes the checking part of the drawings. Any questions on that? Clear as mud?
Clear as mud.
All right. Well, that's too bad. I'm still moving on. Let's see here. The last big key thing I want to talk about is the building codes. When it comes to stairs, I don't have any graphics prepared for that, so I'm just kind of going to talk about it and hope that you understand what I'm babbling on about. And if not, just ask a question. I'll see if I can clarify it a little bit better. So a lot of us are probably familiar with some of the standard building code requirements of stairs and railings. I'm going to talk a little bit about well, generally speaking, the codes that we deal with has to do with stairs and railings specifically. It's pretty rare that we have to go outside of that for some other component, though it may happen. The overall, however, I think it's safe to say that when we receive drawings from an architect, they've already, to get their, permits and everything else with the city, they've already had to draw their stairs to meet building code requirements. So it's usually not a problem. However, with changes on our drawings due to field conditions, or maybe there's changes being made during our design assist stage of the project, it's possible that something's changed enough that it would impact the building code requirements in a negative way and that we need to correct it. So we're going to review some of the big ones here. Stair risers and treads. So I would assume that you're familiar with this. Stair risers should typically be equal height on a flight. So from floor to landing, that'd be a flight of stairs. And all the risers should have the same height. There is an exception to the rule that you can have a variance of 3/8 of an inch at top or bottom or both. But like no one riser should exceed 3/8 from another. We definitely don't want to get in the habit of drawing that in our assembly drawings or our part drawings or when we model it. We want to, as much as possible, maintain the equal riser height. And that 3/8 variance will come into play when they fabricate the stair. If their measuring tape slipped up or something like that, or two guys use two different measuring tapes. Believe it or not, if you pull them out side by side, they don't always match, which is kind of weird to me, but that happens. Anyways, there may be fabrication tolerances, or even when they show up on site, there may be issues with site conditions where we surveys a floor to floor and then they show up on site and the floor to floor is actually off by a little bit. Maybe they didn't field measure the same thing, or if there's a finish applied to the top of the floor, the guys who did the finishing maybe added too much material or not enough that we didn't anticipate for, and so we would still have that 3/8 that we can play with on site if we don't include it in our fab drawings. So fab drawings try and maintain equal risers, and that allows for that variation to be worked with in field or in a shop if there's issues going on there. One thing we don't want to do is for the riser height, we have a maximum height of 7 inches. We want to avoid actually drawing our treads or our risers at 7 inches. If at all possible, try and make it 6 3/4, maybe 6 7/8 max. But if you go at 6 3/4 height, and there's a bus either in fabrication or on the job site, we are not likely to exceed the 7 inches when we're trying to make corrections for it. If you see in the design of the stair, like from the architectural set, that they've drawn their risers at exactly 7 inches, I would highly recommend that you approach to your project manager and you let them know that, hey, we got exactly 7 inches. We have no tolerances for if there's any variations in the field or from fabrication that if we are exceeding 7 inches, we're now no longer in compliance with the code. So the PM may go back to the architect and say, hey, you're really pushing the envelope here by giving us these tight tolerances. Can we convince you guys to throw in an extra step and then reduce the riser heights by, 1/4 of an inch, 1/8 of an inch. So that's kind of like something we want to look out for. But regardless, our maximum per code is 7 inches, and minimum should be 4 inches, which is not really a problem for us. We don't typically have a situation where we have riser heights less than 4 inches. I can't think of a situation where that would have occurred. Stair treads, typically when seen in plan, they're no less than 11 inches nosing to nosing. And that's pretty much a standard. Sometimes you'll see 12 inches, but for the most part, 11 inches is a standard that pretty much all architects will use. There is an exception to that, and I'm trying to find the file here. And of course, I'm having absolutely no luck with that now, but it's in here somewhere. let me just pull up, and this was, you would have seen that at the building code seminar. Where is it? Circular stairs was, I did have it open, but it's, right, it's measured a little differently because of the shape.
Center of walk.
Exactly.
Yep.
I'm just trying to pull up right here. There we go. So center of walk is still should be 11 inches.
Mhm.
The absolute minimum at the end should be 10 inches. So if you do 11 inches, and as you project your lines, you find out less than 10 inches, your 11 inches at your center of walk line will have to actually get bigger. So I need to increase to some, I don't know, 11 and a half, 12 inches, whatever it is, so that you can respect that 10 inches minimum at the inside radius. So that would be maybe the exception to the rule. We don't
That is-
do,
oh,
sorry. Yep. No,
That
go ahead.
is straight line measurement, not arc length measurement, correct?
Correct. Yeah.
Yep. Yep.
Yeah. Nosing to nosing line. Granted, most circular stairs, even if you measured the arc, it shouldn't vary that much from a straight line.
Pretty close,
Just because they're, yeah, they'll be 16th and eighth of an inch kind of thing, but it's generally not that far off unless we have a really tight circular stair, which we don't really get. They tend to be more ornamental in shape, so they're usually bigger, and yeah, it gives us a little bit more play and wiggle room and stuff. So that those dimensions are between arc and straight should not be all that different. It, obviously it'll show more if you're measuring, say, the overall arc length from start to beginning, and then you draw a straight line across, but it's not really an issue for code compliance here. Yeah, measured straight is what we do. Where's that? So that's the stair tread. Headroom is something else to consider as well in our stair design. As measured from the stair nosing. So if you were to draw a straight line from the stair nosing at the top to the bottom of a flight of stairs, and you were to copy that vertically up, at say 80 inches, there should be no obstruction in there. You should, in other words, if you were 80 inches tall, which is, I don't know how many feet that is, 6'8", I think, yeah, that
6'8".
sounds right. So if you're 6'8" tall, walking down the stairs, your head should not be smacking into anything. If it does, we're not meeting code compliance, and we need to bring that to the architect's attention. So talk to your PM, and they'll get the ball rolling to the proper channels, the general contractor, and then they'll approach the architect, and so on and so forth. We had a situation where, and you might still see that in chat somewhere in our engineering talk. I think this was last week or the week before. There was a question about clearance for stairs in New York. And apparently it was a code requirement of 84. But I think that was just for an egress stair, which wasn't actually applicable to the project. So there was a miscommunication here between, I guess, the detailer and the PM in terms of if the 84 inches was applicable to us or not. I think it's still defaulted back to the 80 inches. So 80 inches should be safe. And actually brings up an interesting point. Again, you heard this during the seminar. Different states will have different code compliance. For the most part, they're similar, but there may be the odd exception here and there between one state and the other. Let's see. Stair landings. What did I want to talk about stair landings? Yeah, so if your stair exceeds 12 feet in height, it'll be required to have a landing to break it up. I guess they don't want the older people or people with bad knees like myself to climb 12 feet of stairs and run out of breath and give up and kind of just collapse. So landing is a little break there that helps, I guess, people just I don't know, catch their breath for a second. I don't generally linger on a landing myself, but it's there. The width of the stair it serves. Okay, so I got to read this one. This caught me a couple of times here. So the depth of the landing should have a minimum depth equal to the width of the stairway measured parallel to the direction of travel, or 48 inches, whichever is less. So the depth would be like nosing of the upper flight to the nosing of the lower flight, right? It should be equal to the width of the stair. So if your stair width is from stringer to stringer 60 inches, your landing should be 60 inches or at minimum 48. If it was 40 inches width between stringers, you would have to go 48 inches. That's your minimum length of landing. Again, the architects are pretty good with that, for their permits and everything else. So that should already be included in the design. Usually our length of stair in plan should not change. Let's see, there are exceptions here. It's more to do with like doors or anything else that might be interfering with the landing. Not really something that we come across all that often, but if the door opens onto a landing, should not reduce the landing by less than half the required width. The door should not project more than 7 inches into the landing. So this is not really something that we look out for. That's the architect will deal with that with the rest of the building when they're working with the other trades. Let's talk about stair nosing profiles. So stair nosings, not all stairs need to have a nosing line. It could be a perfectly vertical drop. And do I have an example of that? And let me just close this one here. Maybe I do have an example of that in one of my models. Maybe not that one. Let's try and turn on this one here. No, that's a bad example too. Okay, well, never mind. I kind of kiboshed everything. But let's say let's say for kicks and giggles, let's just see if I can show up this view here and double click. Was it this one here maybe? Yeah, this is a slant, but it's quite possible that we may come across situations where risers go perfectly vertically down. It kind of looks like it is. Is it?
Mm-hmm. Looks it.
No, it's just slight angle. So yeah, it could be perfectly vertical or it could be recessed in. So the nosing basically of your tread could stick out. The most it can stick out by is 1.25 inches from the face of the riser below. So your overall dimension as measured, say, from this bottom corner here to your top nosing line should not exceed 1.25 inches. The other thing as well is nosings should have a raised edge of at least 1/16 of an inch, but not more than 9/16. And so we're talking about this profile here at the very corner. They want this rounded. So if you were to fall and smack your head on it, it's not going to cut you like a knife. Heaven help us, it shouldn't be that sharp anyways, but it should you should have at least a small radius on there. I strive for between 3/8 to 1/2 inch. Architects will typically on their drawings have at least a generic detail of a tread and riser component, and they'll show if they want like a larger radius nosing or not. And most of them are pretty good at dimensioning that. Not all of them do, however. So if you do have to dimension something, it kind of depends on the type of material you're using. If it's wood or precast terrazzo. If it's precast, you may want to go something a little smaller, or maybe like, I don't know, 1/2 inch is probably a good number to use, and the architect can kind of review that after the fact if it's during the drawing submittal process. And if they agree with it, they'll okay it, and if not, they'll let you know what they want to change to. So yeah, nosings need to be radiused. Moving on to, so that's pretty much the stair structure there. Stair guardrails. So guardrails is going to be an interesting one to talk about. And by guardrails, I think you all know what a guardrail is, right? The glass railings that you see on a stair and floor openings. There we go. And let's just hide those camera views because that's a lot of camera views. So building code for a railing, whether it's at a stair or a floor, is 3'6", measured either from the top of the floor, finished floor, or measured from the nosing line on a stair. We want to add an extra 1/2 inch to that height. And the reason for that is that if the floor finish, say there's terrazzo being applied after the fact, if the subcontractor is very generous with the material and applies a lot more material than what we expect, that's going to build up the floor higher. And if we had initially installed these railings at 3'6", but there's more material on the floor, then we're now going to end up with less than 3'6" overall height to finish floor. So that 1/2 inch allows us a little bit of wiggle room for any kind of condition that might pop up on the job site where you know, that floor might have crept up. Maybe we did only partial survey and there's a spot further down the railing where the floor height actually went up by at most half an inch. Right, it buys us that little extra wiggle room where we can stay within code compliance and not have to worry about, oh crap, now we have to raise all our railings up, you know, quarter of an inch because a guy put a quarter inch more terrazzo than we expected. So that applies to all our drawings. So every drawing you'll see, if you've looked at any sample drawings or anyone else's drawings, you're typically going to see that top of railings for us, we will always draw it at 3'6.5" minimum. If the architect is asking for something like 4 feet, we don't add the half an inch. We're already well above the 3'6" minimum. So that extra half an inch, we're only doing it to the minimum code requirement. So that's going to be what we talked about right here. Stair handrails, similar to guardrails. So handrails also have a minimum code requirement. They need to be, I believe it's 2'10" from top of floor or top of finished nosing to the top of the handrail. So 2'10" is the minimum code requirement. And again, similar to the guardrail, Synergy will always add a half an inch to that, so that we're actually designing our handrails to be 2'10.5" inches. So if there's an issue with the stair, if they're building out the wood finishes, maybe the fabricator is kind of goofed on a number somewhere and the nosing sticks out a little too far up or too far to the side or something, you know, we are still stay within that code requirement. We don't have issues with the code, because we built into the system a half inch of play and you know, for adjustments. So that's the right there. Handrails at the top of the stair will extend past the nosing by 12 inches minimum. So I'm talking, what I mean by that is when you're looking at stair, wherever the handrail finishes above the last nosing at the top, we are going to extend our handrail horizontally. It doesn't have to be straight out. It could kind of wrap around a guardrail, but it needs to be 12 inches minimum past this crank point, if you will. Okay. So if you see something where it's 11 inches, 10 inches, you know, 11 7/8, that's no bueno. We can't work with that. It needs to be 12 inches. If it's possible, the architect may have had some kind of a, you know, an exception to their permit where they're allowed to do less. Great, you know, that's on them. But we will always strive to make sure that we do at 12 inches. And again, like I said, if it conflicts with the architect design, you know, bring it up to the PM's attention, or maybe make a note of it in the drawings that it is extended to 12 inches to meet code requirement. And the architect can decide for themselves how they want to proceed. If they want to override us on that, as long as we have it somewhere in writing so that we cover our own little butts, you know, we don't have issues later on. At least we'll have that in writing from the architect. But yeah, top of the stair, 12 inches horizontally. At the bottom of the stair, however, doesn't need to be horizontal. But it does need to extend past the first nosing, or last, I guess, depends on your direction of travel. But the handrail termination, it should be equal to a tread width after the first nosing line. So if your tread width are say 11 inches nosing to nosing, then this the handrail here should terminate. Hang on, what's going on here? Should terminate 11 inches past this nosing at minimum. If your tread widths are 12 inches, then this point would have to be 12 inches past the nosing line here. And it doesn't need to kick out horizontally after. It could die right into the floor. It could, you know, it could just stop right there in the air if it wants. There's no requirement for a horizontal extension there. When working with handrails, and this is generally not a problem for us, the diameter of the handrail shouldn't be less than 1.25 inches. We often use 1.5 inch diameter tubing, or sometimes it's wood. At most, we'll use 2 inches, but we don't go more than that. And that's for round profiles. If we're doing something rectangular, like a flat bar type of handrail, the perimeter should be no less than 4 inches and no greater than 6 1/4. So for this example, 4 inches perimeter means that they wouldn't be able to use a 2-inch wide flat bar by ½ inch, right? If you add the 2 inches top and bottom plus the ½ inches on either side, you end up with 5 inches. And sorry, no, yeah, we'd be fine. Never
Mhm.
mind. Bad example. Forget what I just said.
I understood where you're going with it though.
All
You
right.
couldn't use quarter bar.
Right. Yeah.
Oh, no, it still would be.
Well, yeah. So maybe inch and a half, quarter,
There you
inch and a
go.
half, 3. Yeah. So that would be an example there. So inch and a half by ½ inch you wouldn't be able to use because that would give you a total perimeter of 3.5. And we'd be less than 4 inches. So no bueno there. Let's see for ramps. Okay, we don't do a lot of ramps. We do occasionally have ramps if it's an accessibility thing or it's built into the stair. This may be the exception to the 12 inches horizontal that we talked about briefly here at the top of the stair. So for a ramp, you would have that 12-inch extending past the nosing at the top and the bottom horizontally. So yeah, I think that's pretty straightforward. Handrails, return to walls. Okay. So we may have situations where we have a railing that we're installing up against a wall, or it's maybe the glass railing continues on. Maybe there's a floor opening and the glass railing needs to continue on past where the stair would typically end. But we don't need to continue the handrail along the length of that floor. And so we need to return that handrail back towards either the glass panel or the wall finish or any kind of structure behind. We need to kind of return it. And the idea behind that is we don't want someone walking with a backpack, a purse, some loose clothing, and have it snag into an open-ended handrail as they're approaching the stair and going down, and then that loop catches into the handrail, hits a bracket, and it throws them off balance and they fall. Or worst case scenario, there's a fire and you got a fireman going up the stair with a coil of hoses on it wrapped around his shoulder. You don't want that hosing to get snagged in the handrail either. So we want that handrail to return to the wall or the glass as much as possible. And I might maybe be able to pull up a sample of what it is I'm talking about here somewhere. Maybe if I'm super lucky. It's a drawing done by others. Please be there. Please. Well, that didn't work out. Nope. Here, maybe. Was this job? No, maybe. No, that's structure. Nuts. Well, okay. So I don't have an open example, but maybe I'll forward you a copy of what I'm talking about. But in plan, if I was to sketch something out real quick, say you have your wall line here, and you have your handrail that does here. It's offset by say 1.5 inches. And let's make that say 1.75 inches. That's your wall here. Right? We wouldn't have the handrail terminate like this going down. We'll want this handrail to kind of return to the wall. And it'll either be rounded or most typically we do like a mitered cut.
Okay.
And in addition to that, we will leave a bit of a gap between the wall and the handrail of about 1/4 inch. So that allows if the wall varies, the drywallers aren't always the best, most precise trade in the world. Framing could be off a little bit as well. So that wall may have a bit of a wave to it. We wouldn't want that inconsistency to be like the far point kind of interfering with our handrail if we were to design it flush with the wall. So we're going to usually draw it about 1/4 inch away from the wall. And so if we don't have any conflicts with the structure when we show up with our finished handrail and install it on the site. So that's generally what I mean with the handrail return to the wall. Handrails shall return to the wall. Clearance. Okay, so that's what we talked about there. Okay, clearance between the handrails and the wall or glass panel. So in plan view, again, we're looking at this handrail. The minimum clearance should be 1.5 inches. I think, did I read that right? Yeah, 1.5 inches. However, again, because like I mentioned, there could be some inconsistencies in the wall that could move in or out. So we'll try as much as possible to build in an extra maybe 1/4 inch. So instead of 1.5 inches minimum here, let's see if that dimension line pops up decently. Yeah, I might instead show it to be 1.75 inches. And so if there's any variations in the wall, it doesn't creep into that 1.5 inches. We'll still have some safety margins there. Having said that, we do come on occasion come across a situation where we're using brackets, handrail brackets that we may order from a vendor. They're prefab, they're pre-made, and they're designed a specific length and offset from, say, if it's a glass applied handrail bracket. The design will have been made so that it is exactly 1.5 inches. So if that's the case where we're using a bracket from a vendor instead of something that we are fabricating ourselves, then that 1.75 inches may have to revert back to the default 1.5 inches. So that would be the only time I think I would be forced to use 1.5 inches. If that's not a constraint, like if the bracket is not an issue, then like I said, try and be a little bit more on the safe side and draw it at 1.75 inches. But code is 1.5 inches. So as long as we have the 1.5 inches, we're fine. Openings and guardrails. You may or may not know this one. So in a guardrail, you can't have any openings greater than 4 inches. No gaps greater than 4 inches anywhere within that 3'6.5" height, or well, 3'6" really, if we're talking building code. So in this instance, I have a glass panel butting into the stair. This little joint in between here, I can't have that bigger than 4 inches. Picture having a ball that's 4 inches in diameter. If it can fit through an opening, it's no good. We need to narrow it down somehow. Generally not an issue between glass joints, but it could be a problem where we are tying our glass panels to, say, where it dies into a wall, or sometimes it happens where we have a curtain wall, right? To the outside, there's a curtain wall. I don't know if you're aware with what curtain walls are, but there's like mullions and glass panels, and these mullions can kind of get in the way of the glass panels getting close to the actual glass unit of the exterior wall. And those mullions can get large at times and may force sort of like the edge to be more than 4 inches to the glass. And I'm going to see if I can sketch it out there just so I make a little bit more sense what I'm talking about. Let's say we have a sealed unit 1 inches by, I don't know, let's just call it 30. And we'll make that a nice shade of, I was going to go blue. Say that's a curtain wall. We have a mullion that's maybe 6 by 2 inches. And those mullions will be, I don't know, maybe 1 inch that way. Might be an intermediate mullion somewhere. And we have our glass panel, say this is the floor, and I'm looking at this in elevation, 42.5 inches. That would be at the top of our railings. So somewhere in there, we have to make sure that our edge of glass panel, which would be, say what's in, I'll make it in red here. So that's our height of our railing at a very tiny dimension that no one can read. Which was it? This one here. Try that one. Yeah. Okay. We want to make sure that, I mean, obviously this edge can't go past and into these curtain wall mullions because it's going to interfere with the mullions. Having said that, even if we snug it up tight to the mullion, or as tight as we can, we may end up with more than 4 inches to the glass panel, like in between here. These areas might have openings bigger than 4 inches. So this may be a situation where if that occurs, and I'm using a curtain wall here as an example, it could be something else. What did I do? 12. That to be half. What I would want to do then is notch the glass panel so that it kind of follows the profile a little bit. of what it is that we're contouring around, just to make sure that we maintain that 4 inches minimum clearance, or 4-inch maximum. Sorry, I'm bad with my words today. So hopefully that kind of clarifies a little bit what I'm talking about here, where there might be some exceptions. So it could be a curtain wall. There might be, I don't know, if there's a wall and there's some kind of shelving on that wall. Maybe there's a built-in box for, I don't know, a display case or something. Regardless, if there's any situation along our guardrail that would create an opening of greater than 4 inches, we need to kind of make some kind of an adjustment to make sure that we have less than 4 inches. Now, the exception to that rule as well, and it's not really an exception so much as is just very similar, is on a stair, if you ever have an open-ended stair, and by that I mean a situation where there's no side stringer, your stair riser and treads continue on to the end of, or to the very side of the stair, and you have a glass panel sitting on top, and it's sort of like a triangular shaped opening that's created between the bottom edge of the glass panel running down the length of the stair and the tread and risers. The opening in that, the opening in that can be more than 6 inches, which is right there. So that would be the exception to the rule. We're good on that?
Yep.
Okay, so that pretty much that's the big things for the building codes. Like I said, it may vary state to state, and for the most part, the architect will already take all these things into consideration when designing their stairs. We just need to be aware of it if we have to modify the stair for field surveys or during the design assist stage. We talked a little bit about geometry, right? This is I don't know what they want me to talk to you about, but a little useful presentation there. So it's circle, square, triangle.
I have a question about ovals.
Ask Edward.
Okay.
Yeah, it's not my pay grade. No idea. Yeah, I don't know if they're asking me to talk, and it's something I need to clarify with that, or if they need something to talk about, like, I don't know, trigonometry stuff, angles and stuff like that, just use CAD to figure out your angles and calculate it that way. It's a lot better than trying to memorize the a square plus b square equals c square, or I learned, I'm French Canadian, right? So I learned all my math. Yeah, right, for circumferences or diameters or all that stuff for circles. What was I going to say? Like, for calculating angles, there was like a sinus, cosinus, and tangent, I think is how you say it in English. I could be wrong on that. Yeah. So there's like special formulas in there when you're having triangles that have like a non, I guess, a like a rectangular triangle that has a 90-degree angle on one end, one of the angles. So I'm not going to go through all those formulas with you. I mean, seriously, if you need to calculate the angle, just draw it out in CAD and pull it out that way. Scope. Oh yeah, absolutely. And I've been doing that since I've had access to CAD. I don't think I still remember some of the formulas, but honestly, I don't remember them all.
I forgot most, if not all of them.
Oh yeah.
Tom's old aunt sits on her coffin and hacks.
Yeah, like circles, you can just click on properties too and take a look at it. It'll give you your radius, it'll give you your diameter, your circumference. CAD is great. Love it. Should have had that in high school. Scope of work. So we talked about this early on already, so I don't think I really need to review it much. I talked about how we would typically have something roughly from the design team in terms of what is involved in our. I just need to pull up the sample that I had, and now I can't find it because it's how I roll. There's it's in files, and it should be scope sample. Right. So in an ideal perfect world, we'll have this broken down for us in terms of what profiles we're expected to use, what finishes, and everything else. Now that we're doing more design assist stages, we don't really have this prepared for us in advance. It's more of a learn as you go. With each meeting, things are going to change, and you're not going to know till the end of the design assist phase what profile we're using, what finishes are going to be applied, and so on and so forth. If you have any questions about it, and if you were not provided a scope of work, just ask the question to your project manager. They'll tell you what needs to be done. Sometimes they don't even know themselves, or they're not all that sure. They're just recently been brought onto the project by, you know, a pre-con team or something. So it's good that the question's been raised and everyone can make sure that we have the right information. We don't always have easily accessible to us how they do their pricing, or, you know, or copy of the contract that they hand out to the client. So it's sometimes a little harder for us to try and dig through all the files and find out, you know, what finishes we're expected to provide or any of that information. So if you don't have a detailed scope of work, or if you don't have meeting minutes from the design assist, then you know, arrange a quick meeting with your project manager and just ask a question like, what kind of finishes are we using? What kind of glass panels are we using? You know, what profile should I have? If you know, typically that's usually sketched out by the engineer, so you already know what profile to use for your stringers and plates. But if there's any question about that, yeah, get together with your project manager. They'll explain it all to you, or should be able to, anyways. So I don't know, any questions on the scope of work, like based on what we talked about earlier today and just now?
No.
All right. And the last one, the drawing quality, blah, is more in terms of presentation of your drawings. At least that's what I interpret them to ask me to convey to you. So it's, you know, now that we're 3D modeling and creating our views automatically, some of the old drafting standards of, you know, creating your drawings no longer apply. Traditionally, when you do a drawing, if you're sectioning through something, you use line thicknesses to represent, you know, an object that's been cut through versus an object that's in the background. And these different line thicknesses really help bring to your attention, you know, what exactly the detail represents. In advanced steel, it doesn't work with line thicknesses anymore. It's not something that's built into the system. It may have it with SolidWorks or Inventor. I know Revit has it, but yeah, advanced steel doesn't have that. So we unfortunately can't really represent things that way. So in that case, whenever we're sectioning through something, applying a hatch is very useful. It at least it helps to clarify a little bit more that we're cutting through this object. I haven't had much luck with advanced steel in terms of sectioned views. My hatches just don't seem to appear at all, except unless it's concrete. Then for some reason that seems to work just fine. I don't know why. It just it is what it is. It's driving me bananas. There's a setting somewhere for it. I just haven't figured it out. So if I were to pull like an example here, I'm cutting through an HSS section. There's actually another one here. I have an aluminum shoe that I'm sectioning through. I've got cladding that I'm sectioning through, but the hatches aren't showing up. And this is something that should show up, and I'm going to try and resolve that with Edward to try and figure out what's going on here. Maybe it's a setting in my own file, and maybe for you guys it shows up. I don't know. But you know, that at least helps the client and everyone else reading the drawings understand what's going on with details, more plan views, even elevations, stair sections, so on. Let's see what else. When we're generating our floor plans, but again, because it's based off of 3D drawings, and it's not just floor plans, it could be elevations or details. Because it's generated from a 3D drawing, if you're showing hidden lines, it will show all the hidden lines. And that can kind of complicate a detail by kind of like oversaturating it with a whole bunch of these hidden lines. And when they're really close together and it's a small detail, by the time you print it out, it'll just look like one big solid black blob. So if we can try and avoid like all these hidden lines, like it's hard for me to tell which one's my actual nosing line with all these lines in a way, but that's more of a, that's the unfortunate downside of working with 3D models, is that if you want hidden lines, you're seeing them all. And you can't just delete one line. You're either deleting the whole item that it's tied with, or you just have to be content with living with these extra additional hidden lines that I generally wouldn't draw if I was doing this in AutoCAD.
For visual purposes, can you also do hatch masking, you know, with two-layer color 255 and whatnot, if absolutely needed?
You could. Keep in mind though that if you were to hand this over to say another draftsman, if you get pulled off
Yeah.
this job for something else and the other detailer works on it, they may not necessarily be aware of it.
Right.
And if they modify the model and the size of, like, say we use this tread for an example here, if the tread gets bigger for whatever reason,
Then that's gonna get covered up. Yeah.
yeah. So the hatch may not cover everything else. It might start making it look a little odd. So it's a good solution, and you might be able to use that once in a while, but
Mhm.
probably not as frequently as we would like to.
See, that's one reason why I liked SolidWorks is when I was doing my detailing and or drawing layouts and whatnot. If I had too many hatch lines and stuff that wasn't pertinent, I could right click or click on it and then hide the specific line.
Yep. Yep.
You know.
And Autodesk Inventor does the same thing. You could click on just the one line and hide it. Like in this case, I'd be doing that frequently because there's a whole bunch of these headlines I don't want to see. But yeah, you had that ability. Advanced Steel, however, that line is attached to
That's-
the entire part, right? So you delete the one line, you're deleting everything, even the ones that are
Yeah.
supposed to be visible. So yeah, a little harder to work with.
Right.
So when it comes to plans, I try and right now, again, my experience right now with Advanced Steel is a little limited, so I may not be the best guy to talk to about how to do presentation drawings. But for plans, I just hide lines altogether. Like all hidden lines, I just don't display it, and that's an option you can have here: show hidden lines or uncheck it. So I just uncheck it, and that just gives me the exposed nosing.
Right.
And then if I need to show something a little bit more in terms of like the structural components of the stair, then I either do a separate drawing, like if there's some really special situation, I might do a separate plan drawing of just a structural steel, or rely on seeing that in the section views for the stair, and then hope that the section views kind of convey all the internal structural members that's in there.
Mhm.
Not that there's a lot in this particular example here that I'm showing, but so yeah, Advanced Steel kind of limits us a little bit in terms of our presentation, graphically speaking, anyways. The other thing to consider is to take a note of is when you're dimensioning or labeling your drawings, try and avoid having dimensions and labels kind of overlap, say, one another. I've seen this on a few occasions where I had text right over the dimension, and you don't see the dimension here, but like sometimes you'd see in the other drawing from someone else. It might just be like a little thing like this, right?
Mhm.
So if you can spot that, just try and fix that if you can. Same thing, like you shouldn't have symbols and dimensions kind of overlap like this, and then it kind of makes it hard to make out what part is. It just looks a little sloppy.
Yeah.
So just clean up the drawings as best you can. Avoid dimensioning if possible. Avoid leaving your dimensions like right inside like other parts and
Yep.
components where they overlap. Sometimes you just can't get around it because it's a complex detail. But if possible, like try and put out somewhere where there's a clearing or at the very outer edges of the detail. And that way there's no confusion in terms of like do dimension line, like what's a dimension line? Is this a dimension line or is this a dimension line? Maybe not a good example to show here, but maybe for this one here where you have multiple parallel lines that are kind of in line with the geometry. It might be a little confusing if you have this one here all of a sudden pop up in, why can't I drag this down right here? No, okay, that's still not something like that, maybe. But I mean, you try and keep it neat. Try and keep it looking a little bit professionally, like professionally drawn. I can understand sometimes situations occur where you just can't put something where you'd like to dimension it. You can't quite put a note out in the open. You only have room like inside a spot somewhere, and that'll happen. Just do your best to try and keep it looking neat. Also, when you do your page layouts, if possible, try and leave a little bit of an opening somewhere on your page so that the architect or the general contractor have room to put their stamp on there to say, approved as noted or revise and resubmit or whatever. There's usually 1 or 2 stamps that need to be added to a drawing. So don't overcrowd the drawing too much to the point that you don't have room to put a stamp. I'm not going to necessarily tell you, oh, it's got to be at the bottom right corner or anything like that, but just anywhere on the drawing they can fit in. Actually, I probably could have just moved that over a little bit this way here and left room here. I mean, other than that, cleanliness is it's quality. I don't know what else to say really. Something else I've noticed in drawings done by outside out of house detailers is they'll add dimensions, and for some reason, some dimensions have actually like bigger fonts than others, and I don't get how that works exactly. I'm sure there's a setting somewhere, maybe like so. I don't know, like this. So you have the occasional dimension that's like way bigger than the rest, and it just kind of looks a little sloppy when that happens. So whenever possible, again, try and match it. I mean, there's no reason why it shouldn't, but try and match the text height and have it consistent all across. And same with the notes. Don't have notes that is one size and the next one is 2 times bigger or something like that.
As long as the settings are all set up correctly, it shouldn't be too much of an issue.
Yeah. I think I've seen this happen, and the reason it might happen is probably because they cut and paste a note or a dimension from maybe another detail.
Yeah.
And then don't adjust the scale.
Yeah.
So that's the only thing I can think of that would cause this issue. I mean, maybe there's something else, but you're right. By default, I mean, if you're using a specific style for your dimension or a text style or whatever, it should be consistent throughout.
Right. Don't forget your little 1 foot right there.
Yeah, no, I'm not saving this sheet. No, I'm going to delete that. Yeah, so I mean, it's presentation. We're trying to, I mean, drawings are essentially the first thing the client gets from us as a product. And if the drawings look good, they'll have confidence in that we can do our work properly. If the drawings look bad, they're going to be a lot more attentive to the kind of work that we do. They may be giving more comments that might kind of slow us down a little bit in terms of our design and fabrication processes. We want the clients to feel comfortable with us and expect that we know what we're doing. And that really starts with the drawings that they see.
Right.
If all we did was give them mock-ups, then, it's no big deal, but they see our drawings. So that's kind of key there. We want to try and look professional. We're trying to portray ourselves as knowing what we're doing. And I hope everyone does. At least set some stage in their career. But that's the goal. Just keep drawings looking neat, presentable, clear and concise. And I haven't completed this set. These are design assist drawings, but I haven't completed this yet. But also, make sure that you're including things like your weld symbols, these are advanced steel generated labels here, but I typically hide that and create my own just to reference proper numbering styles and whatnot. But again, try and keep it clean. Your size of your hatch should be such a small scale that it just looks like one big solid mass. Your line types scales, I know in Advanced Steel is being a little fussy with me as well. It should be set in a way that if it's a hidden line, it looks like it's a dashed line and not just one solid line continuous across. So you may have to play around with your line type scale with that. And I've had to do that for some reason. I don't know what's going on here. And well, there we go. I just did it. So something funky going on with Advanced Steel there. I'm still trying to work out. And then I could just match properly that with everything else. So yeah, keep your drawings presentable and clean. Use the same size font, same size text height. Use exact profiles. Here's maybe another kind of big one that is in Advanced Steel you're gonna have to be a little careful with as well. If you're sectioning through something that is, say, like an HSS profile, you should set it so that the display of the profile is actually showing these rounded edges. If we use the Advanced Steel default, I think it's just standard or something like that in a model. If by right-clicking it, you would see like in your display type, you got standard features exact. Standard just shows like a basic kind of like square shaped profile or square shaped beam or something like that. Doesn't really show any angular surfaces or any rounded edges. It's great for modeling, but presentation, it's we're going to end up with a situation where we're showing something that's actually got sharp corners. the architect may actually expect us to deliver a profile that has sharp corners.
Yeah.
So if it's an HSS, we should, in our details, if at all possible, given what we're working with here in terms of the software, we should be showing rounded profiles to match the actual shape of the profile.
Now, shouldn't that actually go right back to the model?
So when you're modeling, as you're modeling, by default, I think and I'm trying to see if I can maybe just this is the wrong one. I want this one here, and I want to show the. Oh, that did a whole lot of nothing. But say it's this one here. Can I just isolate that? So when you're modeling something, by default, it draws it standard. There is a setting you can change it so that it displays it in some other way. But you model it standard, and it kind of helps you snap to like these corner points and whatnot, instead of trying to do like an apparent intersection or something else.
Yeah.
But if it's set at standard, then when you create your detail view, it will apply the standard look to that detail. And if you want to show rounded, then you have to go to the
Can we permanently change that so it always comes in as exact?
Yeah, there's a setting, and I think I listed that in my little where the heck I put it?
Yeah, you change the list.
Well, label, grid line, holes, representation. Yeah, right here.
Perfect.
So beams should be set to exact to more accurately display the shapes, so angles, round edges, and everything else. So default beam general, and you'll see this little item here called representation type for beams exact.
Perfect.
Should be set to exact. That's a setting there that you want to use. So I'll forward you this file, and you can see that there and kind of know what to change.
Okay.
Like I said, sometimes it. Yeah, sorry, go ahead.
I was just going to ask if you could also forward us that the link to that your training.
Yes.
Yes.
Yes. I'm going to send all. I'm going to send all of that probably today as soon as I find the time there. So there'll be that. There'll be this. I'm going to send you a copy of my. No, I don't want to close you. I want the template. So if you want to use that for a basis when you do any checking, if you needed. There's probably something else I'll forward to you as well. I'll have to see what it is. I sent Jeanette a bunch of files. I'll just basically have to copy the files that I sent her and send it to you. Some of these may be like, so these spreadsheets here that you're looking at, these are actually on my Google Drive.
Right.
They're not actual spreadsheets. So I'll send you the link.
Yeah, I'm going to copy them out, pop them into my own Google Drive. That way I can make my own notes and whatnot on it.
Yeah. Or you can download it as PDF or spreadsheet or whatever. You have that option there in Google Drive. So I'll provide that. I don't think there was anything else really I needed to be
all right
to talk about. So that should complete it.